Untuk acara pagi ini kami akan mulai dengan sesi briefing dari AWS terlebih dahulu. Mohon disimak untuk sesi briefing kali ini.
Selamat pagi, selamat datang di Westin Jakarta. Perkenalkan, nama saya Sony. Sales Prevention yang incas pada shift pagi hari ini akan memberikan safety briefing secara singkat. Hotel ini dilengkapi dengan fire lab safety equipment, di antara alat pemadam kebakaran, smoke detector, sprinkler, public announcement speakers, dan emergency response team standby selama 24 jam. Saat ini kita berada di lantai ground, ruang East Java Ballroom, dan untuk emergency terdekat berada di sudut dari ruangan ini. Apabila terdengar keadaan darurat melalui pengeras suara kami, diharapkan tetap tenang dan tidak panik. Tim emergency respon kami akan mengarahkan Bapak Ibu menuju assembly point. Assembly point kami berada di Jalan Epicentrum Selatan, tepatnya di seberang dari lobi hotel. Kami pastikan bahwa hari ini tidak ada latihan evakuasi. Dan untuk informasi tambahan, toilet berada di seberang dari ruangan ini. Dan area luar, lobby east, itu untuk smoking area. Dan Bapak Ibu bisa menemukan praying room dengan menggunakan eskalator naik 1 lantai. Apabila terjadi gempa bumi, Bapak Ibu sekalian dapat melakukan 3 hal ini: drop, cover, dan hold. Dan demi kenyamanan bersama, diharapkan barang-barang berharga milik Bapak Ibu sekalian tetap dalam pengawasan. Kami sarankan untuk di ruangan ini tidak diperkenankan untuk smoking, vaping, atau e-cigarette. Demikianlah yang biasa saya sampaikan. Terima kasih atas perhatiannya. Selamat beraktivitas.
Selamat pagi semuanya. Good morning everyone. Terima kasih sudah datang. Selamat datang ya di training AWS. Welcome to all participants for AWS training. We really appreciate your coming here. And first, I would like also to acknowledge and appreciate AWS for their effort and also for the collaboration with the Ministry of Health to do this meeting. I know this is very important because we are now having the Precision Medicine Initiative been up and running, and again, the data and information infrastructure is very important to support this initiative. So we think that capacity building in this part will be very essential. So on behalf of the acting head of the BB Bionomica, I would wish all of you a good discussion for this meeting. Please don't hesitate to ask as many as question you have, because we have the experts here, and please do share experience and do the networking with all the participants here. Thank you very much.
Oke, baik, terima kasih Bu Iren atas sambutannya. Kami juga mengucapkan selamat bergabung untuk para peserta yang yang mengikuti kegiatan ini via Zoom dan live streaming YouTube seperti itu. Oke, menginjak ke acara selanjutnya akan ada materi dari Dr. Charlie selaku AWS Genomic Industrial Lead. Untuk waktu dan tempat kami persilakan.
Okay, good morning everybody. Very nice to be here today. Thank you BGSi for inviting us to be at this event, your second anniversary. And we are very happy, right, to be here today to be presenting a workshop. Hope that you have a fruitful workshop today, right? And we'll be presenting some of the services we have to help you, right, in your genomics research, and to really fulfill the title to unleash your genomics data, right, to make the most out of your data today, right? So my name is Charlie Lee. I'm the genomics industry lead for Amazon Web Services. I'm based in Singapore, right, but I cover Asia Pacific, Japan. And we have been supporting Indonesia, right, in its efforts for its precision medicine program, right, for the past 1.5 years. So working with the BGSi team, right, on this initiative. So very happy to be here. So today, I will go through some of the efforts we've been doing regionally, right, and how AWS services can help you unleash your data, right? Okay, so for precision medicine, I think everybody here is with a common kind of motivation to help improve healthcare, right? From where we used to be currently, which is kind of a reactive, right, to healthcare. Only when somebody has a disease, then you start treating them, and mostly it is a kind of fits-all treatment, right? So where there's no individualized treatment for the patient, right? You get a one-size-fits-all, and some of it may work, but many of them does not work effectively for many patients. So we want to really improve this kind of healthcare treatment, right, to a more proactive kind, where we are able to utilize the data that you have, the genetic data you have, or all of the data, right, regarding your medical history, where you are, environmental factors, your lifestyle data, right, all of that, how can we utilize them to improve your health proactively, right? So that may be, seeing how, what are the risks that you have for certain diseases, right, to, giving you the personalized treatment, right, certain kind of dosages of medicine or certain kind of treatments which will be more effective for you, right? So that is where we want to have for personalized treatment. And there's really a lot of data that we can tap on today, right? There's basically two kinds. One is the multimodal, where we are looking at clinical data, medical history, and even some of the new technology that you are wearing, the wearables, right? Your heart rate, your temperature changes, right? And all that can be used, right, to predict your health, to monitor your health. And we're also looking at multi-omics data, right? So from the DNA, the RNA, your microbiome, your gut microbiome, your skin microbiome, right? Epigenetic changes, right? So all this data can be used as well. And the real challenge is how to integrate them together, right? To make sense of what's happening to your body, right? And to really get the insights that is able to help you to maintain your health. So for a lot of the organizations, they are looking to modernize their kind of healthcare, right, setup, right? So if in this kind of diagram, you will see that you will have a lot of input, right, from different sources, which is from the EMR, right, electronic health records, your wearables, even your billing, your medical history, all your testing, diagnostic testing, even whole genomes data, right? So that can be your input. And you have your external data as well, right? Because externally, there's a lot of public resources, the publications, the databases, right? How do you integrate all those data as input, right, into your system? After that, then your modern data architecture should consist of a few things. One of them is, do you have, can you make sense out of all this through analytics, real-time analytics? Can you use AI ML, right, to make certain prediction, make certain insights? And for data sharing, that's also a very important part of a modern architecture, right? So right now, I think a lot of the data are still in silos, right? And a lot of the collaboration is contained within your own group, right? But I think to advance research, there's really a need, right, to collaborate outside of your own group, right, within organizations or even globally, internationally, right? So those are the things that we look forward to a modern data architecture. And at the whole kind of background to this, right, is how do you ensure security, privacy, and how do you govern the data, right, such that all this data is traceable, right, trackable, auditable, right, and then you have to comply with whichever standards that you have and regulations, right? So all that can be done. And who are the users of this architecture, right? So those are the researchers, the clinicians, and even the patients. So later I will bring up some examples of real-life examples of how users, right, can take advantage of this modern data architecture, right, to deliver healthcare to the patients and to the clinicians. So to have this modern architecture for healthcare, there's a lot of challenges, right? So from a lot of conversations that we have with the healthcare providers and some of the people we have been helping, right, for their genomics research, right? So those are the major challenges that we find, that we see, right? So firstly, there's a lot of data being generated. If you look at the current kind of just for genomics technologies, right, you have data for whole genome sequencing that is 100 GB, 150 GB per patient, right? But if you're looking at long read data, right, I think next door there's a long read seminar also, right? So if you're looking at long read data, it's 500 GB or even up to 1 terabyte per genome, right? So those are the data size you're looking at. But every day there's also new applications, right, coming up. For example, single cell, spatial omics, right? So those will be combined with imaging as well. So imaging will have a lot of data, right? So those are the kind of application, new technologies. They are coming up every day, right? Which takes a toll, right, on your data storage, on your data management, and how do you analyze them, right? So the data volume is very big and ever increasing. Secondly is how do you manage the cost, right? With so much data to store, to manage, to analyze, how do you effectively manage the cost? And that also includes setting up of your infrastructure, right? So are you spending a lot to build up your on-premise infrastructure every time? No, there's data is being generated, right? And how do you maintain all your infrastructure, right? So those are the cost issues that you need to take note of, right? When to handle this kind of large data sets. And there's also an increasing need to share data. As I mentioned, there can only be innovation and all that if you are able to collaborate, right, effectively, right? So not just with your own team internally, but also regionally, internationally, across multiple kind of parties, right, to really share data effectively, and also to communicate within the same page, right? So some of the pipelines you run, are they of the same version, right? So if different people run different versions, there are also difficulties in communicating. There's also interoperability, right, to consider. So those are the main challenges, right, regarding data sharing and access. Lastly, right, so to build this platform, right, the healthcare platform is not easy, right? So you have to utilize a lot of resources, experience, particularly in a production setting, right? So it's probably all right if you do it in a research setting where it's a one-off, right? You do your research and then, that's the end of it. But to build this healthcare setting in a production kind of standards, right? So you have to take care of a lot of things, right? Including security, audits, right? Compliance, right? And audit trails, right? So all that, can it be taken care of in a better way, right? Than you're currently what you're doing, right? So those are the challenges we normally see, right? When we are talking to our customers and then engaging with them. So for us, our mission is to help you, the researchers, the clinicians, right, the healthcare providers, right, to better make use of your data. How can you get the most out of your data sets, right, to make insights, right, to do research? So that is our goal. That is our mission, right? And that can be achieved in a few ways, right? So we provide kind of the features, right, regarding security compliance, such that you do not have to build everything from scratch again, right? And your kind of setup can be easily changed. It's very flexible. If you need to set up something and you set it up wrongly, right, so you can easily tear it down and then rebuild, right? So that's one of the really cool features about our cloud infrastructure. Right, and you're able to utilize the cloud to enable access, right, control access also, right, to your collaborators easily through trusted research environments. So later we will also have a talk on one of our partners, right, for trusted research environments. So you can see how easily you can do that through the cloud. You're also able to innovate, right, using our features that is available to you at your fingertips. Right, so for a lot of the servers, infrastructure on premise, you are using what you get, right, for the next few years until you're able to upgrade. So if tomorrow there's an application that needs machine learning, right, or AI, right, so GPUs and all that. So if your data center does not have that, then you're stuck with it, right, for the next few years. But with the cloud, all these are usually quite available, right, and then you can start to use it just by going through the web portal and provisioning it, right, rather than spend the money to build it or wait for it to come. Okay. So some of the things that we've been supporting in this region, right, in particular, large-scale genomics efforts, right, across the region, precision medicine. So I'm from Singapore. So in Singapore, there's also another well-known precision medicine program, right? The 100K, SG 100K. We are sequencing 100,000 genomes by the middle of next year, middle 2025, right? But the next phase is also going to start next June 2025, phase 3, which is the 500,000 or even 1 million genomes, right? So that's the ultimate goal for the Singapore precision medicine program. Right, Indonesia is halfway through right? The 10K. So very nice effort from them as well, right? And we see that across the region, if you are aware, Malaysia just announced, right, their My Genome, I think a few weeks back, right? And there are other countries as well doing similar things. So we really want to help and support all these regional national programs, right? So apart from the national programs, we have also been helping a lot of academic research, right, across the institutions, across the universities, and also healthcare, right, by setting up end-to-end clinical diagnostic workflows, right? So we're helping all these genomics kind of a community, right, to build up their capabilities and to do genomics research. And of course, we're also helping a lot of commercial companies, whether they are pharma, startups, and all that, right? So many of them are using AWS. Right, so here is a snapshot of some of them, right? So you can see from the page, right, that many of the sequencing vendors are our partners. So you have Illumina, Oxford Nanopore, right, BGI, right, PacBio. We are working with them on many efforts across the region, right? You also have many startups, pharma companies, Moderna startups companies who are our partners as well. They offer solutions, right, on our platform, right? So those are some of the major players in the genomic space, in the healthcare space that we are working with. So for us, what do we provide? So for AWS, those who are new to AWS, right? So we really provide a host of solution, curated portfolio of solutions, whether it is native solutions or managed services from AWS or from our partners, right? They cater to the whole workflow of genomics, right? From storage management, data management, workflow automation, right? Data governance and aggregation, right? To tertiary analysis, trusted research platforms, to finally build your application. Right. So this is an example of how you can leverage our partners to build an end-to-end clinical workflow, right? So I think in a hospital setting, you always start with EMR, EHR, your electronic health records, right? Then going down to the LIMS, right? So we have a LIMS partner for that. And to build your genomics kind of a workflow, right? So there are multiple partners, right? All the way from data generation, right? So from the Illumina, the ONT, those will generate the data. How you can transfer the data, right? From the sequencer to the cloud, right? So in that way, then what are you going to use for data analysis, right? And data storage, data management, right? So if you have a good bioinformatics team, a good IT team who is savvy in cloud, you can of course build your own applications, right? But many of the organizations, as we've talked to, doesn't have that kind of big teams, right? So they do leverage a lot of our partners, whether it is a system integrator partners who can help you to build, right? Or you take it off the shelf from some of our partners here who are able to provide kind of platforms which are user-friendly, have a user interface, right? Do traceability, cost management, all for you. And you can start using them almost immediately, right? The setup is usually a few weeks. After that, then you can start to use, right? So all these things are available, right? And if you want to generate reports, clinical reports, right? So all these, we have partners for that as well as trusted research platforms, right? For you to share data, right? So all this can be done through our partners who run their solutions on AWS, right? In a scalable and a secure manner. Right. So there are two examples I really want to bring out to you today, right? So first one is, of course, our national program, which is very similar to what you're doing in Indonesia, right? Some of the experiences we have. So we are into our second phase of the program, which is phase 2, 100,000, right? But we also went through a time where we were doing our POC, proof of concept, with the 10,000 phase 1. Right, so that was in 2017 when we did that. Singapore started that. They actually started with an on-premise kind of infrastructure, right, for this 10,000. Right, so that was back in 2017. But however, they quickly found out all the limitations of that. I think according to people who work with it intimately, right, so they until about slightly over 1,000, 2,000, right? So that's where they started to really have a lot of challenges, right, using the on-premise system, right? So there's a lot of manual work to be done. There's a lot of things that needs to be integrated, right? There's a lot of security concerns as well, right? So that is the challenge, right? And when you're dealing with such a big data sets, right, you are also you need to share, right, the computational resources, whichever institute you are who's managing the data, with all the other researchers, because it's not just this project, right? So that's where also the challenge is, right, about sharing resources, right? So if you're working on it, then the other researchers will not be able to do their own research, right? So that's one of the major bottlenecks as well, right? So they quickly realize that, and then switch over to the cloud, AWS, and they are able to, and they haven't been looking back since, right? So once they switch over the cloud, for that phase 1, right, they started to realize the power of the cloud, how they can better utilize the cloud for this kind of large-scale analysis. And today, in phase 2, right, they are totally on the cloud, right? So you can see from this phase 2, 100,000. So there's no way, if you started to talk to some of our partners, some of the people who really implemented the system, right, in Genome Institute of Singapore, in Precise, there's no way that you can do this on the on-premise infrastructure, right? And from the first top right corner, right, so that's where they began on phase 1, right, to until the bottom right corner, right, you can see where they are in phase 2, right? So everything is now on AWS, right? So with our partners, right, Illumina generated the sequence, run Dragon and Illumina connected analysis, they're all on AWS, right? And then passing the data to GIS, to Precise. And that's where the repository is, the AWS bucket holding all this data, right? And that's where also the next phase, which is very important, right? So what they want to do with the data, right, is to actually share it and give access to the researchers, right, within Singapore. And we are starting to see that a lot now, right? Many of the researchers from the different universities, from the institutions, are now tapping on to this data, whether it's the initial 10K data or the first part of the data, which is the 50K, right? So once all this data is in the AWS S3 bucket, right, the researchers who is in different universities, different settings and all that, can easily access the data, right, through the AWS backbone infrastructure. Okay, of course, you need to set up your kind of approval process, right? So not everybody can just go in and get the data whatever they want, right? So you still need to go through an approval process. Comes up with you need to submit like what is your research and all that, why you accessing it, how you want to access it, go through the necessary approval, right? Then through the cloud, they can grant you the access that's needed, right? Certain data or raw data you're not able to access for this project, then that can be easily configured by the administrators, right? So that you will only get the access that you're granted to, right? So that is challenging, right, to enforce in the on-prem infrastructure, but quite easily configurable in the cloud settings. Okay. And recently, I think maybe you also saw the news of a new project, which is the 10,000 long read flagship project, right? So from the initial 100,000, that is all on short read, right? They have a new project, which is 10,000 long read to build the reference genome, right? For Indian, for Malays and for Chinese, right, in the Singapore population, right? So that is also a very important scientific kind of discovery, kind of initiative, right? So you will start to see the new projects and new ideas, right, being brought out for this precision medicine program. So that is also run all on AWS, right? We're working with Oxford Nanopore, we're working with PacBio, right, on this, right, to really accelerate this project, right, in Singapore. So I hopefully Indonesia, right, is able to do the same as well. We're supporting fully, right, on our part, right, to try to help you guys to accelerate your own national precision medicine program. Another example I want to bring out is how you can utilize, right, AWS for your clinical kind of settings, right? So recently we had a symposium in Canberra, Australia. So this is one of the keynote examples of how an Australian organization is able to utilize AWS to bring kind of a modern healthcare, right, to their patients. So this entity is called the Australian Epilepsy Project, right? This is in collaboration with the Florey Institute, right, and also with the University of Melbourne, right? So their patients are epilepsy patients who typically takes about 15 years, right, from their journey from diagnosis to treatment, right? Because it's difficult to diagnose epilepsy, right, and also other mental issues, and how do you treat them? So usually it's a very long journey for this kind of patients, right, to get the appropriate treatment. They want to shorten this, right, to months rather than years, 15 years, right? So they try to leverage the power of data, power of the research data, right, to try to help these patients. So what did they do? They actually leverage on 4 different kind of pillars, right? So the first one is research. There's a lot of research data out there. How can you easily combine them, compile them, make sense of it? Can you use them to create a baseline report for every patient that comes in, right? So that you can, based on that baseline report, right, the clinicians can make better decisions, right, for the patient. Secondly is the network, right? So can you collaborate with the with the institutions, with other hospitals, right, who are experts in this area, right? Can you do effective collaboration with them, right, on all this to try to help your patient, right? Thirdly, how can it benefit the patient itself, right? So the patient, when they comes in, maybe they are not so familiar with their own condition, right? Can you generate some kind of report, or is there some interface, right? Or is there some mobile application to help them manage their illness, right? Or to have some more information on what is their treatment about, what is their kind of drugs about, or any queries about the disease, right? Or can the application help them to change their lifestyle, right? So that is the kind of benefits directly to the patients that they want to implement, right? And lastly, to build a platform, right, for the clinicians as well, right? Can everything be displayed nicely onto a platform, right? So that everything is available at your fingertips, and then that is a very nice decision support system, right, that you can implement, right, for the clinicians to really impact healthcare. Okay, so they actually came up with this brain health platform that's built on AWS. So from the data sources, I think from the brain platform, they have a lot of MRI scans, right? And they have different cognitive testings, right? Survey results, and even genomics testing results, right? So all that can be combined, right? Medical history, right? Everything can be input sources. And there's a few components, right? So, which is very common in clinical genomics, right? How do you automate all these things? Because there's so much data, right? From multimodal sources, multi-omic sources. How do you integrate all of them? You probably need to put them into a data lake for easy query, easy access, integration, right? how do you process the image from the MRI? Can you extract features, right? So from that, correlate with the genomics data or other medical history, clinical data. Can you utilize machine learning, right, to enable all of this? And lastly, to build the kind of browser, right, for the client, for the customer, for the patient, for the clinician, right, and also mobile browser, right. So all this is for the benefits of all the users, right, on the extreme right. Right. And all of this, right, can be done on AWS, right? So there's a few components there. You have the data and storage layer, right? Whether it is for current data storage or for long-term archival, right? We have solutions there. Governance, that is also very important. Who gets to access your data? How do you authenticate the users, right? So all that can be done as well. Control, automation, analytics, AI, ML, right? So how do you leverage technology, right? The latest AI, ML, maybe the Gen AI, how do you leverage that, right, to build your applications? And of course, security is very important, right? How do you secure all this patient data, privacy? Can you do it with encryption, right? Encryption at rest, encryption at the transfer, right? So all these things is also very important. And how do you detect threats, right? How do you detect attacks, right, from external, right? So all this can be built on AWS resources, right? And today, I think our solution architects will go through some of the services. Hope you have a good workshop to learn how you can start to do some of these things, right, with our services. And this is a snapshot, right? So the keynote lecture was quite very interesting, very detailed on their innovations. So this is a snapshot of what are the key innovations they have implemented. Firstly is the clinical portal, right? So once the patient comes in, you have all the scans, you have all the medical history, you have all the kind of communication, right, with the clinicians, right, even at the GP level, right? So all this is available in the clinical portal, right? So all these are there, right? And you have the medical history explorer as well, right? So, and the patient summary, right? So they actually have a report generated by AI, right? Gen AI, where you have a very clear report. And they also made a nice innovation where the text, right? So they were able to differentiate which text, right, indicate with icons, which texts are generated by Gen AI, and which texts are factual, right? So Gen AI may infer something, right? So, and write kind of suggestions or inference. So those texts are actually marked with an icon, an AI icon, to let the clinicians know that this part is generated by Gen AI, right? And what are the parts that are factual, right? Just extracted from text or from clinical trials and all those things, right? So there are innovations that are coming up, right, to help and to integrate, right, how Gen AI, right, can be used effectively in such a clinical settings, right? They also have implemented the OHIF viewer, right, to extract the features and to have suggestions on how to what's happening to the images. And lastly, there are also things such as the suicide risk prediction, right? So for many of these patients, they have a tendency to have suicide, but then with the Gen AI, right, through the questionnaires, some of the questionnaires, and through the interaction, they're able to have a risk prediction, right, on whether the patient has a tendency to commit suicide. And then those with a high risk, you can actually tend to them first, give them more attention, right? So those are the things, those are the principles that actually you can leverage, you can extract and extrapolate to other diseases as well, right? Can you extrapolate it to, for example, cancer or certain kind of hereditary disease, right? So all these components of it is easily extendable to other diseases and how you manage those diseases and patients. And I think one very important fact is also that they wanted to have an explainable AI, right? So when you are doing all this kind of prediction, right, one important thing is to ask the AI, right, to indicate what are the features, right, that led them to make this suggestion or to let them have this inference, right? Those are actually important, and those are also reflected in the report or in the platform, right? So it's just not just a black box, right? They're able to explain to you what are the factors that contribute to this decision in the end, right? So ultimately, I think this is a platform to help the clinicians, help the patients, right? It is definitely, and the speaker also emphasized, it is not to replace the clinicians, right? It is a platform to assist, right, in decision making, make it faster. Because he also talked about the experience of going through such change, right? Of course, initially the patients and clinicians may be skeptical, right, of such a platform, how to use AI, will I be replaced? I think through the kind of POC and I think this was implemented for about 18 months as a starting, right? So it's been 18 months since they implemented this, and the feedback initially, of course, there was some pushback and all that, but after the 18 months, actually the feedback was very good, right? So these are some of the impact that we see, right? So for patients, right? So since until now, right, there's about 830 patients going through this platform kind of treatment, right? And then we see higher retention rate, right, from the consent to use the data, right, for research, and also follow-ups, right, using the mobile applications and all that. There's a higher retention rate. You also have democratized access to advanced diagnostics, right, whether it is genomics diagnostics or any other kind of new technology. Once they are more aware, once they know how they can benefit them, they actually help them a lot to go with those kind of technology. And you're able to fast-track treatments as well, right, with the knowledge that you have, right, from previous research, from clinical trials and all that, that really have a benefit kind of the patients a lot. And for the clinicians, right, so those are the clinicians' kind of feedback on how they were used. So the portal and all that, you're able to generate reports much faster, make the diagnosis much faster with the information that you have on hand, right? You're able to also help patients that otherwise you have been missed out, right? Maybe with the genomic testing, right? With all the advanced technology that you have now at your fingertips. So you're able to help more patients, right? From the ones that are missed out, right? So really, I think this has an impact on how we can improve the healthcare of patients, and also how clinicians are able to utilize technology, right, to better their treatment, right, and to spend more quality time with the patients, right. So those are the two examples I brought to you today, right. Hopefully you have a good session today, right. So let us know, right, how we can support you in your initiatives. Talk to us. We'll be here, right, the whole day, and hope you start your journey, right, your cloud journey with us. Thank you.
Oke, jika tidak ada pertanyaan, mungkin kita bisa lanjut ke materi berikutnya. Oke, baik, jika tidak ada pertanyaan, maka kita akan lanjut ke kegiatan berikutnya, yaitu Trusted Research Environment yang akan disampaikan oleh Bapak Dimitri Wiryo Wudoyo. Baik, waktu dan tempat kami persilahkan. Having that trusted research environment will help move this issue. And hopefully the data custodians or the platform administrators of such TRA system are responsible for the research sharing.
Thank you. And this data custodians can manage the different access control. Because Charlie also mentioned about data governance. How do we ensure that, this person or this user can only access this data A, B, C, and C, maybe only genomics data set of this set of patients. So when we talk about TRE, what we have built so far is built on top of the 5 SAFE framework. Safe people are they who they say they are. Safe projects is the project or their study they're doing is, are they doing it the way that they're supposed to according to the ethics approval, for example. Safe settings and data, are they doing it in the correct environment with the correct appropriate data governance policy, and of course safe outputs, because we still have to retain the privacy of these individual subjects. So that's also a brief overview of what TRE is. I would like to take some time now to explain BC Platform's TRE solutions, which comprises of BC Insight and BC RQuest. And these 2 applications work on the principles of the 5 SAFEs I mentioned just now. So on the left, we have a couple of different functions or abilities that you can do in the system. This platform, BC Insight, can be the platform of choice to ingest, store, and manage multimodal data, including pheno or clinical data. And we can even combine those phenotype and genomic data together. Or even when you start exploring further, you have methylation data, transcriptomics data. BC Insight can be the platforms of choice where you can combine all these different pheno, geno, or other omics data, and you want to query them, like, do we have this particular cohort with this inclusion or exclusion criteria? And if we want to start talking about inviting external collaborators, probably we do not want to just give them free reign access to all the single data points that we have in the platform. We want to just here's a sneak peek of our data. Is anything of interest to you? Essentially a data catalog. And that's what BC RQuest does. We provide this platform where external collaborators can, it's basically a web application. You go on there, do you have this cohort, for example, cohort of myocardial infarction with this age, but not having this and that. So that's the 2 components of the trusted research environment that we offer. 2 of some. And of course, in terms of deployments, we are very flexible where this can be deployed. Most major cloud platforms are provided, on-premise also supported. But in my personal experience, across the different customers that I have been involved with in the Asia Pacific region, AWS has been their cloud infrastructure of choice. So a bit more detail about the TRE. So in the bottom left, we have BC Insight. So that application sits behind the institution's firewall, for example. And when an external collaborators want to browse the data, they come in on the top left. They are outside of the firewall. And again, they would have to check first, does the institution actually have the data that they're interested in? Say that they do. What happens next? And in BC Insight, we have a component there where we can create an isolated working environment only containing that data. So the external collaborators, they can come in, make an application for the project request, I found this cohort of interest. Can I get access to that? And provided that the appropriate documentation has been submitted, approval has been given, they can then go into bottom right, which should say BC Insight Workspace, if the resolution could be better. the data that they have requested. Okay. And of course, in order to be able to provide these, secure and safe access environment, we are committed to complying and to be adherent to different data security standards and regulations, of course, in different regions. And these are some of the customers that we have where our applications have been deployed thus far. I'll talk a bit about some of these customers. First of all, we have HDR UK. They are using BC Request, where as their platform of choice for data cataloging and where they can, like, oh, what kind of data do you have? And second example is this consortium, like in a European consortium called OncoValue. And this consortium or collaboration aims to develop novel AI-based tools to automate the collection and analytics of clinical data and other types of data in real time to ensure that novel cancer therapies are effective. And this is done, as I mentioned, in different countries or different sites in Europe. And finally, one case that's a bit close to my heart is this Helios. Helios is one subset of the cohort as part of the Singapore National Program. And the Helios cohort, they have multimodal data. They have different omics data. They have genomics, whole genome, they have methylation, they have transcriptomics, they have clinical data, and they have questionnaire data. They have a lot of data, essentially. And BC platforms, BC Insight and BC Request primarily, have been selected as the platform of choice. Again, this is a case that's very close to my heart because I've been involved since the pilot phase of the project and deploying this, the production environment. And then also now that we have been in this collaboration for quite some time, we continue to further our collaboration by collaboratively working on co-development projects. So those three are some of the selected case examples of where BC Insight and BC Request have been deployed. So I've been chatting about TRE, just slides. What on earth are you talking about? But like a picture says 1,000 words, and I would like to maybe just give a brief live demo of what our applications can do. One second. It's loading now. Okay, maybe I'll start here. Can I get the screen? Okay, thanks. Right, this is an example of BC Insight. What I have actually done here is that I pretended that I was an external collaborators. And as you can see, the data set is quite limited. Sorry for the resolution. And in this study, this simulated study with synthetic data, what I have provisioned is that, I have a set of data surrounding subjects who have been diagnosed or who have had myocardial infarction, heart attack. And in the original data set, there's about 250,000 data, 250,000 subjects data. But because I've only created the project only for subjects that have been recorded to have had myocardial infarction, the number of subjects have actually gone down. So we have different data sets here. We have the demographics data, stuff like age, gender, something like blood type maybe. We have diagnosis, because not only that they have had a heart attack, but they may have had other diagnoses in the meantime. Encounters, like, when the records, when they actually visited clinics, hospitals, emergency care, lab tests. As the name implies, we have also medication and procedures. So these different data sets only contain the subjects. Again, from 250,000 or so, we have limited the scope of the data that this external collaborators can see to only about 40,000 subjects. But 40,000 may still be quite a lot, especially when you're doing, maybe rare variant research or something like that. Is there any way that we can further refine this set of samples? In BC-INSA, we have this, if I can find my cursor, function called cohorts browser. And what we can do in cohorts browser is that we can build virtual cohorts on top of our existing data. If my internet's working. Okay. So I have made, maybe I'll show this first. So I can create a new cohort. And before I create a new cohort, what it will do, the system will go through the data that you have access to. And then it will show you how many subjects that you have. So for example, we have about 42,000 here. I'll just make it slightly bigger so it's easier to see. And if we want to start building virtual cohorts, like, okay, you have a cohort who have had myocardial infarction. Anything else that we can see in the data? And we can start to build different filters. We create inclusion or exclusion criteria on top of this data. And we are able to see the different tables that we have access to. And each table, we have different variables that we can further filter. Maybe you want to look at a particular lab test value, or maybe you want to look at if they have any other diagnosis. And I've made a cohort just to look at any other diagnosis other than myocardial infarction. Oh, yes. And I've created this dashboard where we're selecting those who do not have a myocardial infarction or have been previously diagnosed with myocardial infarction, but maybe have some other diagnosis. So as we can see here on the group on the left, which is our filtering or inclusion exclusion. Oh, boleh. Much better. Okay. It's okay. Yeah, bye-bye. Where was I? Okay, I mentioned earlier about having different diagnoses, and we can also create different dashboards just to get a quick overview of what our data after it has been further filtered. There are different types of visualizations available. And for example, here I've created just a distribution, like pie chart of the other diagnoses that this cohort might have, and also the sex distribution. Okay, so that's a very brief example. But maybe you want to further explore the data, like what else can we do now that we have our virtual cohort, our data set? How do we start running analysis? Now, in BC-INSA, we have integrated a couple of different analytical solutions. One maybe that's a bit more familiar to many people is notebooks. So we have notebooks. not that one. And in this notebook, we have different programming languages available. I know a lot of people like to use Python, but I know that a lot of people in the biology realm prefers to use R. And if R is your programming language of choice, we also have RStudio built in. Now, we have notebooks integrated. Is there any way that we can fetch our data rather than like download and then re-upload, read it into a data frame? Why can't we just read the data from the data that we already have access to? And there is a package that we have baked into the integrated Jupyter. If I can see my screen over there. Come on. And this package would allow you to fetch the data using SQL-like syntax, and then make that data set available in the context of the notebook itself. So I'll just wait until it shows. Okay, that's taking longer than I thought. And having that data means that then you can start doing a lot of things to it, right? You can start doing basic visualizations. You can start doing your statistical analysis. I'm not sure why it's taking so long. I apologize. Come on. Okay, there you go. So we have this special package called BC Jupyter Import, which allows you to fetch those data in your tables into the context of the notebook itself. And if you are a bit more, like scripting savvy, then of course you can use API calls to other data providers. And maybe, in recent years, like, LLMs, ChatGPT, whatnot. Feel free to use that as well. In this example, I have actually made a call to an LLM provider where I sent my data, only if that's allowed, okay? Not endorsing anything. And I asked it to summarize what data I have in my, summarize my data, what type of different diagnosis, just getting like an overview of the data. And I get an answer because I sent my data away. And of course, if you maybe are concerned or have particular interest in ensuring data privacy regulation, to be adherent to data privacy regulations, maybe you want to deploy this model a bit closer to where your environment is. And of course, get the answer back. And the other thing that you can also do is visualization, as I mentioned earlier. If you need some additional packages, if you're using Python, pip install, done. Some scripting, just getting the data again. And finally, we can call the plotting. And we can save that plot or even have it here. So this is just an example of a dummy data visualized. I've created, again, about 250,000 data, 250,000 subjects worth of data, and simulated some dummy conditions, some dummy diagnosis, some dummy lab test values, and so on and so forth. And we can just see the heat map of, like across different 5-year periods over the, I don't know how long this was. We have had different diagnoses. And of course, if you are a bioinformatician, maybe like, notebook maybe not be enough to run, my like downstream analytics after getting a sequencing. And in that case, we also have Nextflow. So if you are experienced with Nextflow, then you can write your own script, of course. if you're happy doing that. But if you maybe want to using something like established pipeline, for example, from the NF core community, then you can just simply paste the pipeline in this page. And of course, if you have your data in S3 bucket, for example, we can then just choose like, oh, this is my sample sheet and containing the list of FASTQs or list of BAMs, VCF and whatnot. Just submit the pipeline there, however long it may take, and then you'll be able to get the results out. And the beauty of this is that this next flow is also integrated with the application. So you can get your data back into the application itself, into the tables, or if you want to further process the data downstream, back to notebooks, then you can import those data into the notebooks again. Maybe you're running transcriptomics analysis, and you want to do something like a differential expression analysis using DSEC or Lima, and you just export that back to a notebook, fire up your RStudio, and run your analytics there. I mentioned earlier about data governance. So in this example, I have only provisioned 6 data sets. But if you may want to, for example, you have a different projects, and you want to invite different collaborators in, then you can just spawn a new workspace. So we create another isolation based on top of our data set, and we can only let the selected people to come in, do this kind of analysis, data browsing, data querying, and then get the analytical results. I think I am almost at time. So I hope this gives you a brief overview of what trusted research environment is all about, in particular BC Platform's flavor of trusted research environment. If you have any questions, Janika and I will be here today and also tomorrow, and we're also happy to take any questions now or at the side. Thank you very much, everyone.
Okay, thank you, Mr. Dimitri, for your presentation and your workshops. Maybe is there any question? Ada yang ingin ditanyakan terkait diskusi materi saat ini dari tim yang ada di dari peserta yang ada di sini atau dari Zoom? Oke, baik.
Hi, I'm Ririn from BGSi. My question would be, can you elaborate more on the method that you use to standardize the data input before it, gotta be gathered in the trusted
Of course.
data?
Of course. The question is like, how can we standardize the data
Yes,
before we actually
and whether
get
it's
into
also
the platform?
included in the service.
Not quite. So essentially, it's really up to you how you want to define your data model. Maybe you have a local data model. And that's sufficient enough. And having your own local data model will still allow you to do the cohorts query, creating those dashboards, that's fine. But if we want to start talk about standardizing the data, maybe, for example, we have different data models. Diagnosis, we have SNOMED or ICD-10. Lab tests, we have LOIN codes. Medications, we have RX norm. You can also use those data sets. And especially if you want to start collaborating internationally, maybe we want to have a more internationally recognized or more established data model. Then for that option, the one approach that we can do is to still have your data, SNOMED, ICD-10, ICD-03, whatnot, but we can do a separate standardization layer on top of that to, for example, something like OMOP. Yes. And
but is it the OMOP? It's something that that we have to do before we share it, or is it kind of like optional?
It's optional.
Okay, so the next question would be, is it also allowing for federated data sharing?
Yes.
In that case, how can we standardize? For example, Indonesia have BGSi and Singapore has BGSi. And if we would like to combine the data, if there is no such a method that both BGSi and BGSi use to standardize data, how can we kind of like share it?
Yes. If we want to start talking about international collaborations, then we need to just agree on what data model would be appropriate that are, across different countries, right? BC Platforms actually has this global portal called bcargos.com, where we have customers from different countries actually, and the data model of choice on top of their existing data is to convert that, whatever data model they have, into OMOP first. And having OMOP, because that the data is quite well standardized, especially clinical data, then you can start talking across different collaborations, even internationally.
Thanks.
Thank you.
Okay, thank you, Bu Ririn, for your question. Is there any one else to share their thoughts and discussion, open to discussion for this session? Ada yang ingin diskusi lagi atau bagaimana untuk sesi kali ini dari Zoom atau dari yang udah ada di sini? Oke, jika tidak ada, mungkin kita akan coffee break dulu 10 menit. Setelah itu akan kita lanjut paparan dan workshop dari Mr. Edwin. So yeah, we are going for coffee break for 10 minutes and then we continue to your presentation. Oke, terima kasih. Untuk coffee breaknya ada di luar, silakan dinikmati. Terima kasih. Selamat siang Bapak Ibu. Acara akan segera kami lanjutkan dalam 1 menit lagi. Mohon untuk para peserta yang masih berada di luar untuk segera kembali ke ruangan. Oke, baik Bapak Ibu, untuk sesi selanjutnya akan kita mulai dengan tema AWS Batch Workshop yang akan didampingi dan akan difasilitasi oleh Bapak Edwin Sandanaraj.
Hello
Okay,
everyone,
baik.
I hope you have a good break, and my name is Edwin. I'm a genomics solution architect based in Singapore, but I closely work with healthcare genomics opportunities across different parts of the world, in particular in the APAC and Japan. So we have been involved in multiple projects like a UK Biobank and Singapore Precise and New South Wales Health Pathology and Japan Genome Cancer projects and Korean cancer projects. So I'm delighted to be a part of this conversation today. We will be going through some of the hands-on exercise on the cloud. I'm just like to know, particularly I would like to introduce my colleague August over there. He's our eminent senior solution architect based in Jakarta to support your needs in here. And I would like to quickly understand how many of you have been already using the cloud or any cloud. Any show of your hands, please? Not many. Excellent. Okay. Yeah, I could see a few hands. And today, the workshop objective is in twofolds. One is we try to get you the exposure of the cloud operations. When your organizations or Ministry of Health say your data, we have our data hosted on the cloud, you should not be having any hesitation to jump on the cloud and access those data sets. So you'll be getting the exposure to that. And second, you should be able to perform some of the analysis using our readily bundled our tools, which we already packaged based on some of the best practices. So you should be having exposure to that. So before that, I just quickly draft few of the solutions which have been used by multiple global research parties. So the first one I would like to show, you have been generating the volume of genomics data sets when genomic sequencing machines have been generating, how you can move the data sets from your local service centers or local sequencing center, or even from your local storage environment to the cloud. So in cloud, we operate based on the concept called infrastructure as a code. So you deploy your infrastructure in the code format. So you just deploy your coding, and all of the cloud services will be deployed at the background. So all the necessary components will be deployed. So you don't need to manually create a server or initiate the server, but this code will invoke the necessary services to be implemented in the cloud environment. For example, here, is the laser pointer? Okay. So, for example, your sequencing machines have been generating that cow. So what is the way that those data sets can be synced from your local environment to the cloud S3 bucket? In the cloud, we often called as a S3 bucket, which abbreviated as a simple storage service, which is the storage container. You can just imagine like a bucket where you can bring all of your data sets. It could be of an application, it could be of a document, it could be of a genomics FASTQ file or BAM, CRAM. Cloud doesn't care, basically. It just treats everything as an object. So all the data sets can be bundled in one place called S3 bucket. In that S3 bucket, you can manage with a lot of tags where this particular data set come from, which hospital. Even you can just add additional information like what disease cohort it belongs to. So these are the major informations you can just bring in. So as you could see here, the data sets comes here using a data sync service. The data sync allows you to sync your data sets for any new incoming data sets from your sequencing mission. Whenever the new data sets arrives from your sequencing mission, this will automatically detect and it automatically sync the data back to the cloud environment. Either you can just leave it to the data sync to be making the sync in an automated way, or you can just do it in the periodical settings, like every 2 days, it should sync all the data sets to the cloud environment. Once the data sets reach the cloud, what is the best practices you can do it in the, for your data set? For example, if you're receiving your FASTQ files from your sequencing center, these FASTQ files are going to be used only once. Once you processed it to the BAM or CRAM or VCF, these FASTQ files may not be frequently touched or may not be accessed. So these data sets not needed to be on the hard storage environment. This is kind of a cost prohibitive, it's expensive. So what we try to advocate is, once the FASTQ files are processed, this data set should be moved to the cold storage tier. This gives a lot of 1/10 of your cost savings when you store the data in the cold storage environment. So this also can be done in an automated way. So you can set the lifecycle policy, as you could see here. There is a policy, you can set it like a FASTQ files should be moved to the lower cost storage tier after 2 months, because in 2 months' time, you might have done the processing with the different pipelines. Genome variant calling, or for example, RNA-seq, you might have done a transcriptomic quantification. So these FASTQ files can be safely moved to the lower cost storage tier. We call it as the S3 glacier. You just imagine it is a cold storage. So this gives a 1/10 of reduction in the cost. For example, 1 terabyte of data sets can be stored with the $2 cost in the cloud environment. So this is the cost savings you would like to implement when you manage a very large volume data, such like what the population sequencing effort is happening in the BGSi. And everything can be automated here, as I mentioned. So the whole infrastructures can be accessed by this QR code. Once you get in this particular link, there will be a cloud formation template will be available, which is in the YAML scripts. You can directly invoke this YAML script in the AWS Cloud Formation Service. The whole infrastructures will be built under your own account. So you can set the periodical settings of your local path, then it automatically sync the data sets into the cloud S3 bucket. And the second component, which we'll be mostly doing on the hands-on exercise today, so which is a compute. So the genomic data sets have arrived in the cloud. What is the best way to run the analysis in more automated fashion, basically? So what we do is we have multiple different ways, like one way is to run a secondary analysis, and the secondary analysis will be done in a more automated manner. For example, even your variant calling pipeline or RNA-seq pipeline might be including the different tasks, alignment and variant calibration or base quality corrections, and then the final variant caller will be called for that particular variant. Each of those tasks may be requiring a different compute resources. For example, your alignment task may be requiring a 40 CPU mission, whereas your SAM tool indexing might be requiring a 2 CPU mission. So how we can automatically scale up and scale down those compute resources? Instead of provisioning one big compute server like 70 CPU missions, and if you're running the whole task in that particular mission, it is an overkill for certain tasks. We don't advocate to do in that particular way. We try to provide those automation through some of the services called AWS Batch, which is a managed scheduling service which dynamically provision the required compute resources. 60 CPU mission is needed for alignment job. This 60 CPU mission will be given for only that particular task. After that task is completed, that 60 CPU will be withdrawn from that environment. Then the next task will be running in only 2 CPU mission. In that way, we can efficiently run the compute analysis in a more cost-effective way. We will be doing some exercises on that. On the second component is a data aggregation. We won't be touching today, but this is a very, very critical component. Even BC platforms also touched on that, how you can integrate different modality of data sets and run queries on top of those integrated data environment. For example, you are bringing electronic medical record, you are bringing a genomics data set, you are bringing some longitudinal data, post-treatment data set. How we can run and extract the necessary biomarker from here. Now the things are moving towards the artificial intelligence and machine learning. How we can bring the machine learning component to learn the pattern of those integrated data sets and derive the insights from that. So this is one way we can run programmatically, or you can even leverage in the GenAI component to ask the questions on top of those particular data sets. For example, a clinician comes here and he wanted to understand about a particular patient, how he is comparable with the other responder cohort. So you can easily make these kind of queries on top of those integrated data sets. For that, we need to have one of the point our eminent audience had mentioned, that data standardization, how we can make it as an interoperable, how we can run those integrated data sets in a queryable format. So as I mentioned before, do you mind, can I have a pointer? Pointer, you have any? So in that, so there are a few ways you can run your compute analysis. As I mentioned, one is the AWS batch, which is the managed scheduler that helps you to dynamically provision the compute servers or resources that required for each of those tasks in the pipeline. The second way is we have built a wrapper around the AWS batch, which is called Amazon Genomics CLI, which I mentioned at the top. This is mainly to align one of those common standards established by the genomics community, which is called the Genomics Alliance for the Global Health, so GA4GH. They have established multiple APIs. This API can help to make the analysis in a more reproducible way. For example, if your publication requires your analysis, compute analysis is performed to aligning with the GA4GH standards, you should be able to easily mention that this particular analysis is done using the Amazon Genomics CLI framework. So you can easily meet those kind of necessary requirements. Basically, what happens is the Amazon Genomics CLI is we built a wrapper around the AWS batch compute environment. The reason is AWS batch needs some expertise on the compute environment and what kind of a service you wanted to use and how you can prioritize your job scheduling. When you use, sorry. Yes. Here, we can find, okay, thank you. Okay. Yeah, this is helpful. So, it's very difficult for me, sorry. So Amazon Genomics CLI is a wrapper around the AWS batch environment. It automatically creates the necessary compute environment, and it creates a compute fleet of instances, and that particular instances can be used for running the whole analysis. And the last part, what we have recently launched, which is called the AWS Genomics, which is a fully managed service. So we don't need to worry about the compute environment or the job queuing or scheduling. You just submit the input data sets in a parallel manner, and all the analysis will be happening independently in the Genomics environment. So all the analysis will be processed automatically, and those whole results will be directly going back to the individual S3 bucket and the specific folders. So this is mainly try to support the population sequencing large-scale effort data, and some of those large-scale efforts like a Genomics England and the Israel Genome projects are currently running using the AWS Genomics services. And there are two prerequisites, but I cover in the afternoon how we can run the Genomics-based analysis. So Amazon Genomics CLI, as I mentioned, which is an open source CLI, you can directly go and get those code repo from our GitHub, and you can deploy that GitHub repo in your account. This whole Genomics CLI will be automatically provisioned. As I mentioned, the whole Genomics CLI works in the concept called infrastructure as a code. The whole services, all the necessary architecture services will be deployed under your account. As you could see here, there is AWS batch compute environment will be automatically created. The job queues will be automatically created. The context, that means your compute fleet. For example, if you are submitting a pipeline or genomic analysis, that is going to be running in a compute fleet of instances that will be automatically created for you. So you can directly submit your pipeline analysis within a few lines of commands. So that is the exercise today we'll be doing for running the genomic analysis in the AWS environment. So there are a few prerequisites here. You can bring any of your open source pipeline, any of your NF core pipeline, or a VW repos pipeline, or a CWL pipeline. The only requirements is your workflow should be orchestrated in one of those 4 languages, which is mentioned at the leftmost top. It could be of a WDL, or it could be of a Nextflow, or it could be of a CWL or SnakeMake workflow languages. Once it is constructed in those languages, you can directly submit the jobs in the Amazon Genomics CLI. It will be using the AWS batch to execute those tasks here. As I mentioned here, these are the few QR codes if you wanted to access it later, and how you can install Amazon Genomics CLI, which is called in a short form as AGC. So that is the AGC command we will be using it. And some of the hands-on workshop, we already have it prepared, so you can easily use those things. The lines of commands is like, first we have to activate the account. Then you can configure your email to receive the notification. For example, the pipeline has completed or struck or interrupted. And then you can create a context. Context is nothing but you are creating the compute environment instances. Basically, what type of different compute resources are needed for running your genomic pipeline. It is a CPU-intensive compute workload or a memory-intensive, RAM memory-intensive compute workload. So you can give a big blend of both compute and memory-intensive instances. The AWS batch will automatically pick the right compute servers to run that particular task. And then you can get the status of your workflow using AGC workflow status. All are kind of a few lines of single line of command. You can get the output from there. So with this, we are quickly jumping onto the workshop. So let's get our hands dirty on running this analysis in the cloud. So there are 2 ways you can run this workflow account. So this workshop account will be on us. And so we have created the account for individual users. Anyone who just log in here, you will be prompted to enter your email address. The email address could be of anything. It could be of your personal or it could be of your official email address. You will get the OTP, one-time password, to your email address. Then key in the one-time password in the link. Then you will get into the AWS cloud account. So whenever your organization gets the cloud account, usually this is the way you will learn in the AWS cloud environment. And so today we will try to give you the exposure of accessing the cloud environment. This account will be available for you for the next 3 days. So you are free to use it. And there won't be any charge incurred for your organization or for you. So we are free to use it. Even you can try using some GPUs as well. If you wanted to access your analysis and analysis, you are completely free to do it. So either you can go with the AWS_BGSi1 or AWS_BGSi2. Please put this link in your web browser. And once you hit the enter, that will take you to enter your email address page. Then once you enter the email address, you will receive a one-time password to your email address. So the next page will be, you can key in the one-time password. Then you can get into your own cloud account for this particular workshop. So August will be there. If you have any challenges in accessing those links or getting into the workshop account, please feel free to reach, or I will be coming around to you as well. So let's do this whole workshop, interactive, and please feel free to reach us out anytime if you have any challenges or any difficulties. Are you able to access the link, either BGSi1 or BGSi2? It's quite bit.ly/AWS_BGSi1 or AWS_BGSi2. Either one of these links should work to get into this cloud workshop account. Key in your email address then you will receive the OTP within a few minutes, and then enter your OTP inside the next page, and then you will reach the AWS workshop page. I'll be doing with you the whole workshop, and can I share the screen instead of PowerPoint?
Iya, rekan-rekan tadi kalau ada yang nggak bisa mengakses, kalau ada kesulitan, nanti bisa mungkin angkat tangan gitu ya. Nanti bisa saya atau Edwin akan ke tempat rekan-rekan ya, gitu. Ya, terima kasih.
Yeah, I share the entire screen. That's all. I may need to use multiple tabs. Will that be okay? I will open up a new tab as well. Oh, yeah. Okay. So, can I duplicate this? Sorry to disturb you again. Can I duplicate the screen, because now you have extended the screen display, I think. That will be easy for me to access from here. I can do it from the settings. Yeah. Yeah. Oh, yeah. And yeah, thanks. Yeah. So once you have entered your one-time password, you will be reaching this particular page called Review and Join. You scroll all the way down, and then there should be a checkbox at the bottom which says that agree with the terms and condition. So once you have entered the one-time password, then you will get this particular page called Review and Join. Any challenges or any difficulties getting there? Please raise up your hand. August over there, and so scroll down all the way in this particular page, and then checkbox the agree with the terms and condition, and click the join event. At the bottom there is a small orange color button. It says the join event. So click the join event there. Then you will be getting into this particular page. This is the workshop landing page, AWS Genomics Unleashed. Everyone is able to reach here? Excellent. So on the left-hand side, there is an open AWS console on here. On the left-hand side, under the AWS account access, there is an open AWS console link. Please right-click and open it as a new tab. I really want you to keep this page open. Don't close it or move to the next page because we are going to take some information from here. That's the reason why I would like you to open it as a new tab, the open AWS console. On the left-hand side, under the AWS account access, there is a link called Open AWS Console. Click this and open it as a new tab, Open AWS Console. Please keep this page open because we need to take some of the credentials from here. So once you open it as a new tab, this is the management console. Whenever you are an IT administrator or cloud administrator provides you the AWS account, after you logged into this account authentication, you will reach this particular page, which we call it as the AWS management console. From here, you can access any of the cloud services. It could be of a S3 or storage bucket, or it could be of a EC2. August, hold on. It could be of a S3 or it could be of a EC2. EC2 means Elastic Compute Cloud. This is the frequent term we will be hearing whenever you talk about the cloud. EC2, Elastic Compute Cloud, which is kind of nothing but a server. You may be hearing the word like a servers from your high performance clustering environment. We call it in the cloud, we call it as instances, EC2 instances. So you can access any type of service here. The clarity is a little blurred. Let me increase my size. Okay. I hope you can see. So the management console, our exercises is going to be running from the workshop learning page. On the left-hand side, there is a few bullet points on the left-hand side. So these are the exercise page we will be running today. The first few exercises, since many of you are new to the cloud, so we'll just quickly start on how you can open up the S3 environment and how you can provision certain EC2. Then we quickly jump to the AWS batch workshop, which is a slightly advanced workshop. But this workshop link and this cloud account will be available for you for the next 3 days. So you are free to do it at your own pace later at any point of time. So I'm starting from the scratch, like basically how you can access our S3 environment, then moving on to the EC2, which is a compute environment. Then we are going to do the exercise on the AWS batch. So I hope we try to complete by 12. So let's do it fast, actually. These are the exercises we will be doing it. Whoever is already familiar with the cloud environment, please proceed the exercises. Those might be kind of a very, very basic for you, but in the interest of many audience, I'm starting from the beginning. So the first point here is storage. So how to access the S3 environment. So once you reach the management console, there is a search panel at the top. Type S3 at the top search panel. So if you type for the services, from here you can just look for any of those cloud services. So type S3 in the search panel, top search panel, and you will be getting the top hit as the S3. So I'm just opening it as a new tab, S3, or you can just directly click from there. So this is the cloud storage environment, which is a simple storage service. From here, you can create your own bucket by clicking the right-hand side. There is a small orange color button. Can you see this? Create bucket. We'll make it just a little bigger. So S3, this is the S3 environment. Whenever your organization or some of your collaborators have the data set in the S3 environment, usually they will be seeing from here. So now I would like you to create a bucket here by clicking this, and then I'm going to point few of those things. Then you can create your own bucket. The bucket name should be in the lowercase letters, and it should be a very unique bucket. So you can add some random numbers so that you will get this bucket name available for you. So I'm going to create like a test, some random numbers here. Again, the name should be all in the lowercase letters, and you can create your own bucket with any of the name what you want. So once you click the create bucket, the orange color button in the S3 console, you will reach here. In here, you can create your own bucket. Then most of the things I would like you to leave it as it is, because object ownership, we don't need to worry about it. But your administrator will be kind of defining certain policies, how you can create the bucket. But we don't need to, as bioinformaticians or researchers, we don't need to care at this point of time. By default, all the S3 bucket created under your account is blocked for the public access. No one can access your bucket content except you. So if you wanted to open up the access for some other collaborators, there is a structured protocol you have to follow. Then only you can open up your bucket for some specific collaborator. So now we are going to just create a bucket. By default, this is being blocked for the public access. Only you can access this bucket. And the fourth aspect, what I'm going to touch on here is the bucket versioning. The bucket versioning will be very, very critical component when you're dealing with the clinical records or clinical data sets, because in the clinical setting, you might be getting the data sets in the longitudinal manner. So week 1, the patient might have come and provided certain lab test, and the week 3, he might be coming again. He might be doing another lab test. So you may be collecting the data in a longitudinal manner. So if you enable this versioning, you should be able to go back to the previous version of data at any point of time. But now for the genomics data set, I don't think it may be necessary. I don't know. Some of you may be thinking if you wanted to keep it as a different data set. For the clinical records, it will be very, very critical. So whenever you deal a clinical data sets, try to enable this versioning. If you enable this versioning, all the data sets will be tracked for the different versions. Week 1 data will be there, week 2 data will be there. You can go back at any point of time and you can do an analysis. So all these different data sets will be added on an incremental basis. So any new data there, it will be added and updated. And any point of time, you should be able to go back. And the fourth component, what I would like to touch upon here is the encryption, because Indonesia may be having specific regulation practices how you can encrypt the data sets. Most of those healthcare and genomics data sets should be encrypted, so you can rely on what are the encryption practices Indonesian government imposes. So AES 251 or SHA encryption standards, all those encryption standards may be available. You can select which encryption standard you wanted to encrypt your data set, then you can wrap it, the encryption around your genomic data sets. By default, any data sets coming to the S3 environment, which will be encrypted using the server-side encryption at S3. But if you wanted to add additional layer of your encryption, you can use the second component, second radio button. You can select that. That will be an additional enhancement for your encryption, which is called a key management service. You can use it. So now we are going to leave it as it is. And if you open up the advanced settings here, there are multiple options. You can have it here. Either you wanted to lock your objects. If you're collecting the data sets for FDA approval and you are getting the lab results for a particular drug testing. So in these cases, the data set should be locked. So for FDA approval, you may have to provide those locked environment of your data set. Your data set is not manipulated or anything. So you have to lock those data sets here. So that's all. These are the few ways, few options I have highlighted. Either you want to lock your data sets, it's up to you to lock. Encryption, how you can adhere to the governance and regulatory practices of your government. And you can even have the versioning control of your data sets, and how you wanted to share the data sets. These are the 4 different aspects you can set when you create your bucket in the cloud environment. Any questions here? Then you can just click create bucket. This bucket will be created. As you could see, the test bucket has been created now. This is the random numbers. If you face any challenges or any difficulties, any of you got any errors when creating the bucket? If you are getting the errors, there are 2 ways. One is you may have the name in the uppercase letters, or your bucket name might have been taken by someone, because your bucket name should be unique. So that's the reason why we have asked you to add some random numbers in addition to the name of those buckets. So open up this bucket, click this bucket with the bucket what you created now, and I'm going to click this. Then bringing the data from the console, quite very straightforward. You may be doing very frequently a different drive box and everything. So I can just click upload, and you can add the files, or you can drag and drop the files, and that particular files from your local environment to the cloud. So I'm going to just click add. It could be of a file, or it could be of a folder. Anything you can bring here, and I'm going to make a small PNG file, bringing this file here. And one more point I would like to add here is the properties. So if you scroll once you have uploaded the file, and you could see your properties link at the bottom most here. And the properties are different storage tiers actually. By default, any data sets you are bringing to the cloud environment that will be stored in the standard, which is the hard storage tier. If you're going to access the data sets on an everyday basis, you can keep the data sets over the S3 standard. Whereas if you're going to use it, if you know the access pattern of your data set, this data set may not be accessed very frequently, you should be able to bring the data sets to the S3 standard infrequent access. And you see this S3 standard IA, abbreviated as infrequent access. If your data sets are fault tolerant, that means you can regenerate the data at any point of time. For a BAM file or a CRAM file, when you have the fast queue, you can easily regenerate the BAM or CRAM file. So those kind of data sets can be easily get into the one zone infrequent access. Why we are doing this is, whenever you bring the data sets to the cloud environment, it will be stored multiple copies across the different data centers. Usually we call it as a multiple availability zones. That means these data sets will be made into a copy of 3 cluster of data centers. So roughly about 9 different copies are made within the Indonesia region itself. So that gives you the high redundancy of your data sets, that gives you the high durability for your data set. Your data set won't be lost at any point of time. 99.119% of durability we can offer you from the AWS environment. And also at the same time, the data sets will be highly available to the compute environment. If your data set is going to be accessed for the compute cluster analysis, since it is made in the multiple copies, you will get very high availability, so your compute performance will be definitely improved on it. So that is the property of S3 standard. If you're sure about the infrequent access, that means the standard infrequent access, again, the data sets will be stored at the same time, it will be not access frequent. The last 2 components, which I referred in this particular page, is called a glacier. Glacier means which is an archival tier. You process your data sets and you generated the VCF file, you completed your analysis from the different pipeline. These data sets can be kept into the archival environment. At any point of time after 5 years, you found a new pipeline is very intriguing and you wanted to reanalyze your data sets. You can bring the data from the glacier back to the standard and reprocess your data set. So this is the way we try to advocate our end users, how you can manage the data sets in the different storage tier. Because you're not dealing with a few GB of data sets, you are dealing with a multiple terabyte of data sets. So if you're not practicing the right storage tier classifications, you maybe end up getting into the bigger amount of cloud bills. So we very often insist our end users, try to manage your data sets in the right storage environment to get the cost efficiency of your data management in the cloud. So now you can you have the option to select whichever the storage tier you wanted to manage it. So you can select the S3 standard. This is where you want to put your data set, but you are free to select anything. Then I can just click upload. The data sets will be uploaded in a second. So the data sets are landed in the cloud environment, and you are free to share this data set, and you can even have a complete control of here. And one more thing I would like to point here is, any questions on the data uploading or selecting the storage tier? Okay. So the data is already here. There is one more point I would like to make a point. So there are a few tabs: properties, permissions, matrices, and management. So management, how you can automate the movement of your data sets, because now you may not be very sure about your data sets. One way you can leave that option to movement of your data sets to the S3 intelligent tiering. S3 intelligent tiering can automatically monitors the access pattern of your data set. For example, if you have created a BAM file, some hospitals have been already using that particular BAM file to visualize the variant of your patient. And after 3 months of time, the data set are not accessed, the intelligent tiering will automatically move those data sets into the lower cost storage tier. So you can directly put your files into the S3 intelligent tiering. Intelligent tiering automatically manages and governs those data set movement to the lower cost storage tier. If that particular data set are not accessed, the second lower cost tier, then intelligent tiering will automatically move to the archival tier. So in that way, you can leave that particular job to S3 intelligent tiering. The intelligent tiering will automatically manage it. Or if you are sure about your data movement, I really want this particular data set should be moved to the S3 infrequent access after 2 months. Then after 5 months, it should move to the one zone infrequent. After 6 months, it should move to the glacier. After 5 years, the whole data sets need to be deleted. To do that, you can use this lifecycle rules. So the lifecycle rules allows you to, you can create a lifecycle rule, and you can just mention any name, like a FASTQ management. And you have the option to set a prefix. For example, if you have particular data sets coming from a unique hospital, some of your MOH hospital, so you can name all the patients maybe having some unique name before that particular hospital name. So you can just implement that prefixes. And these lifecycle rules should be applied for at least some decent size of your data sets. You don't need to implement this lifecycle movement of data sets for a small file like a 1 KB or 2 KB file. So you can specify the minimum size, like I would say like a 1 GB, at least a 1 GB data set, and or 10 GB data set. And also you can specify the maximum object size. It could be of, I would say like 500 GB. So all the data sets between this data size, 1 GB to the 500 GB, will be applied or will be invoked by that particular lifecycle rule. So the lifecycle rule, you can select, like move all the current versions between the storage classes. I wanted to say, you can select this particular option, move current version objects between the storage classes. And the first rule will be like, I want to move my data sets to the standard infrequent access after 30 days. Then the second transition, I want to say, like, I want to move to the glacier instant archive retrieval to 150 days. That means after 1 month, this hot storage tier data sets will be moved to the S3 one zone infrequent access. After 5 months, all these data sets will be moved to the glacier instant retrieval. And after 1 year, I want to move all the data sets to the glacier deep archival. So these are the three rules which I just created. So these rules will be applied to all the FASTQ files with the minimum data size of 1 GB to the 500 GB data size. And these are the three rules we have been created. And if you wanted to delete the whole version of data, you can select the permanently delete the versions of those. That should be expire. Yeah, there should be a third option called expire current version of the objects. You can select that checkbox as well. So that will give you when these data sets should be completely deleted from your environment. So I'm going to put like a 3650. That means after 10 years, all the objects will be deleted automatically from your bucket. So if you wanted to see the quick snapshot of illustration, so you will see the quick flow chart. Day 0, the objects are uploaded. Day 30, objects move to the standard infrequent access. Days 150, objects are moved to the glacier instant retrieval. After a year, there is going to the glacier deep archive. After 10 years, all the objects will be deleted from here. Then you can apply this rule. So all the data sets in this particular bucket will be invoked by this lifecycle rule. So we created this lifecycle rule here. Any questions on creating the lifecycle? When you're handling this kind of a large volume of data sets, definitely you will be doing it, and you will be documenting this lifecycle as well. Or if you're not sure about creating this lifecycle rule, or if you're not sure about the access pattern of your data set going to be, you can just leave the job to the S3 intelligent tiering. Okay. So we have done the S3 part. Any questions, please reach out to August, and yeah, don't hesitate to reach. And we will be moving to the next one, compute side. As I mentioned before, the first workshop page, that includes the step-by-step left-hand side. If you unpack it, all the exercises which I mentioned now, which is kind of given as instructions, a step-by-step process, how you can do it, how data storage, how data transfer management, and data sharing. So you can do it at your own pace at any point of time. Please feel free to do that. Okay. The second one, what we are going to do is the EC2. So from the management console on the top search panel, you are going to go to the compute server. That means like Elastic Compute Cloud. Type EC2 on the search panel. So you will get EC2 as a first window. You can just click that. So you are reaching the EC2 console now. Then the first thing you need to create a key pair. Key pair means how you are going to connect, because you are going to create your server in the cloud. So you have to connect the cloud from your local laptop or local workstation to the cloud instances. So the key pair will help you to open up the instance access from your environment to the cloud environment. So on the left-hand side, when you are in the EC2 console, on the left-hand side, you could see the key pairs under network and security. Can you see here? Key pairs under the network and security. Click the key pair, and you are going to create a key pair. This key pair needs to be created for each region, actually. So now if you are going to access a compute server in the cloud for the Jakarta region, you have to create a separate key pair. If you are going to create a server in the Singapore region should have the separate key pair. So click the create key pair and name it as a Jakarta region. Or now all the exercises will be happening in the US East, so don't worry about it. But when you are getting your actual account, you are free to choose any region, actually, how you can run there. So I'm going to create a Jakarta key pair and leave rest as it is by default. Just click create key pair. This will automatically download a small key pair to your download folder. So click create key pair, name the key pair, and click download, create key pair. It will automatically download a key pair to the local workstation, local laptop here. Everyone is able to create a key pair? Good. So now we are going back to the EC2 dashboard. On the left-hand side, there is the EC2 dashboard at the top. Please click that. On the left-hand side top, you can click the EC2 dashboard. And there is a small orange button called Launch Instance. Launch Instance means you are going to create your own server, own instance now. Okay? Click the Launch Instance. Everyone is with me? Or I'm going too fast? Okay. I just repeat again. Once you are in the EC2 dashboard, and you can scroll down under the Launch Instance section. Click the small orange button, Launch Instance, and you can just name it Workshop Instance. Instance is nothing but the variation of server, which usually in the cloud, they call it as an instance because of the architecture is completely different from your local compute server. And you can just name it the instance, whatever the name you want to call it as. And you could see under the OS images, there are different flavor of OS images. It could be of a Mac OS, or it could be of a Linux, Red Hat, Ubuntu, whatever the Linux environment you wanted to create. So now for this workshop purpose, you can just leave it as it is default, Amazon Linux 2023, which is nothing but Linux, another variant of Linux. And particularly, I would like pay you to attention here and the instance type. So what type of instance you want to create? So you have the different variety of instances, more than 400 instances will be there. And you can just click it, and it could be of compute intensive instances like Intel processors, or it could be of RAM memory instances like AMD processors, or it could be of GPUs, NVIDIA processors. So now for these exercises, I want you to type like a C5 dot 2x large, which comes to like a 8 CPU and 16 GB memory, or you can just do it the C5x large as well, which comes to the 4 CPU. Whenever you type that particular instance, you will get the detailed information about how many CPUs are available in that particular server, and the whole information you will be getting here. Okay, you can type C5.x under the instance type. You will be getting this C5x large, and key pair, you can, the one which just you have created, Jagada key pair for my case. So if you click that drop down, that particular key pair which you have created will show up here. So you select that particular key pair. And rest of the things you can just leave it as it is. And if you wanted to increase the local ephemeral storage, now it is 8 GB. Sometimes if you are handling a bigger data sets, it may not be sufficient. So I'm going to put it as a 20 GB local storage volume. And that's it. You can just click launch instance. So the two things we are modifying from this template. The one is we are naming our instance, or the workshop instance, or whatever the name it may be, and selecting the right operating OS system images. In this case, we are selecting Amazon Linux 2023. And we are modifying the default instances, which is like a T2 small or something. So we are modifying this to the C5X large for the genomic exercise, and we are selecting our key pair. That's all. So these are the 4 things need to be done. Then you can click launch instance. The instance will be launched. It will take some 2 minutes or something. Then this instance is accessible for you to run the analysis. Okay. Please try and launch the instance. Then we will run few exercises inside that particular compute server. Any questions? But this is just to give you the exposure of how the instances are being created in the cloud. But in the later exercises, what we are going to actually running the genomic analysis, usually it will be done by AWS batch. So AWS batch, we are going to submit the job to the scheduler. The job will automatically initiate the instances and run the analysis. After the analysis is completed, this instance will be taken off from this compute environment. It may take a 1 or 2 minutes time for the instances to be available for you. Please feel free to ask any questions now. So everyone is getting the green ribbon at the top. Successfully initiated the launch of instance. If you didn't get, please let us know. We can help you to troubleshoot it. Yes, please. Agus? Yeah, please, can you repeat for me?
And I was having a hard time catching up with your explanations.
Okay.
Obviously, my interface is different from yours. So
It's different.
I didn't quite grasp what your explanations.
Okay.
So could you please give me a summary, simple summary about your about these steps you have explained? Thank you.
Yeah. Actually, in this exercise, what we are trying to do is 2 things. One is we are creating a storage environment in the cloud. That is the first part of exercises. Creating a storage environment to manage the genomics data sets. That is the first exercise what we have done before using S3. And the second exercise, what we are currently doing is we are creating a compute server to run a genomic analysis, because your workstations, maybe your current laptop may have something like a 16 CPU or something like 32 GB RAM memory. But in the cloud, you have the power of unlimited. You can even create like a 400 CPU machine and something like few terabytes of RAM memory. So this exercise give you the exposure to create a small compute server and how you can connect that compute server from your laptop to the cloud and how you can run the analysis in the cloud instances. That is the quick summary of these two exercises. Agus, can you help us? Yeah. You can explain. Yeah. Okay, this instance may be available for you to run a small analysis. So can you go to the EC2 dashboard again on the left-hand side top? On the left-hand side top, EC2 dashboard, then there is a small link called instances running. Click that, instances. And you should be able to see, if you drag from right to left, and you should be able to see the status check as 3 by 3 checks passed. That means your instances is ready to take any job of running analysis here. So you can just click the checkbox here. And you can just click the connect button at the top. Checkbox that particular instance and click the connect button at the top. I repeat again. I just reached the EC2 dashboard on the left-hand side top here. Then in this EC2 dashboard, there is a small link at the top called instances running. Click the instances running. So that will show you the current instances running in your account. Checkbox that and click connect. Checkbox that particular instance and click connect. So that comes with the instruction of how you can connect to that particular EC2 instance. Okay, don't worry about it. We will do it how we can connect. So there will be a few instructions. Either you can connect from the instance connect or session manager or SSH client. Please click the tab SSH client because we are going to use SSH client to connect the instance. Then you will get the instruction about the 4 steps, how we can connect to that particular instance. Everyone is able to reach here? Good. So the whole process exercises we are going to use from a small IDE called a Cloud Shell. On the top, there is a bell icon at the top. Can you see this? Next to the small bell icon, there is a small Cloud Shell marker here. That is a small command line will be available for you in the browser itself. Because you have created a Linux environment, so you have to use the programmatic commands to connect to the instances. Next to the bell icon, there is a small cursor. Please click that. Next to the bell icon, there is a small cursor on the left-hand side at the top. Click that particular icon. That will open up a Cloud Shell ID, which is Integrated Development Environment, which is a terminal that will open in your browser itself. Okay? First thing what we are going to do is we are going to upload the key pair which you downloaded in your local workstation in the previous exercise. So how to do this? Click the Actions button on the bottom, the Cloud Shell environment. Click the actions here. There should be an upload file options here. Click the actions on the cloud shell, and everyone is able to see here. And under the actions, there should be another second option called upload file. Click the upload file and point your key pair which was downloaded from the previous exercise. Usually that file will have the suffixes PEM. Next to the bell icon, there should be a small cursor, which is a Cloud Shell environment. Click that Cloud Shell environment. So that will open up a Cloud Shell in the same browser page at the bottom. Once you have the Cloud Shell environment is directly available in the browser, click the actions here. And under the actions, there should be an upload file. Click the upload file and point the key pair file which was downloaded in the previous exercise. Okay? So now that file might have been uploaded. If you want to check the file has been uploaded or not, you can type the command ls on the Cloud Shell terminal. Basically, we are listing what are the files are available in the Cloud Shell environment. That will show up your PEM file. Now we can follow the instructions, what was given from the instances page itself. I hope you can see the OpenSSH client. We already have it. Locate your private key file. We already have it. Then the third command, you are going to run it, chmod. We are going to give the permission, change the permission. You can click the two squares on the third line of command. That will automatically copy the line of the third command. chmod 400. In your case, might be the key pair name might be different. So you can just copy the entire line and paste it in your Cloud Shell environment. So I'm going to type this and change the key pair mode. Okay. If you have done the third execution, you can just go here. Under the example, there is a line of command. SSHI, basically you are giving the SSH command to connect to your cloud instance. Okay, click the double square near the example command. The whole line of example command here. Type enter. Then it will ask you, be sure you want to connect to the instance. Give yes. Now you are inside that particular cloud server. Now we are entering into a small server, small instance, like a 8 CPU or 16 GB RAM memory. At the same time, you can get into any of those instances. It could be of a multiple flop of a CPUs and anything. So, okay. So this is the exact procedure, how you can connect to the EC2 instances in the cloud and how you can run the compute analysis in the cloud environment. So everyone is able to reach there. Okay, so the next exercise actually, basically we have given a few lines of command here. How you can provide certain credentials in the exercise. Please do it at your own pace. We are going to jump onto the batch one now. You can do it at free time or your own pace later. So basically, before that, you have to upload certain credentials because you're going to access our data set, like access key or key ID. So far, our exercises are done in the management console from the interface itself. If you are going to really do the exercises in a programmatic way, your administrator has to provide some secret access key and the access key ID. This is specifically for you to access or execute the commands in a programmatic way in the cloud. So that will be given later. For these exercises, you can copy from the workshop landing page. So that the access key ID and the secret access key will be available for you to execute it. So first thing what you have to do is you can just click the get AWS CLI credentials at the left-hand side bottom. If you click the next line below the open AWS console, there is a get AWS CLI, basically command line interface credentials. This credential is necessary if you're going to execute the task in a programmatic way, executing the programmatic commands from your terminal to the cloud environment. So you may request your administrator to provide you with a secret access key and the access key ID. These are the two information is needed to execute the commands from your environment to the cloud. For the workshop, we already given you in this particular line. So you can copy the whole thing. You can just click the two squares on the next to the export AWS CLI. These two squares that will copy the whole chunk of command. Can you able to get here? Get AWS CLI credentials will be available for you on the left-hand side from the workshop landing page next to the open AWS console here. If you click this get AWS CLI credentials, that will open up this pop-up page. This pop-up page will have all the secret access key and key ID information. Then copy this and paste it in the Cloud Shell terminal. Then you are giving the permission to do the job, accessing our open data sets, accessing our genomic data set, and running small analysis and the cloud instance. So I'm just copying this whole chunk of command and pasting into the Cloud Shell terminal. Control V. This will paste the CLI credentials there and type enter. So basically what I'm doing now is, for this particular instance, we are giving the permission to access some of the open data sets, some of the S3 bucket access, and connecting to few instances, installing certain softwares. All the permissions are being issued to this particular cloud instance. That is what we have done now. Okay. So the exercise here on the workshop page, if you scroll all the way down, there are a few exercises. Can you able to see? Or I need to make it bigger. So we already have few data sets available in the S3 bucket. As you could see, S3/GIA basically is a Genome in a Bottle project, which is a Broad Institute's Genome in a Bottle project. Those data sets will be directly available, like NA12878 or different data sets will be already available for you to access it. So you can access or you can download those data sets. So we have given certain instructions how to download the data sets from our open data bucket, like a Genome in a Bottle projects or a NGI Genome, which is another Illumina Genome projects. This is also open data set project. So you are free to access those data sets from our environment. For example, if the NGI Genome include different versions of reference genome versions, like different organisms, Arabidopsis or Drosophila or human, all these organisms data sets will be available. Genome in a Bottle projects, you may have the different sequence technology test data sets, Illumina or Oxford Nanopore, long read, Oxford or PacBio data sets, or even NGI or Ultima Genome. Those different technology test data sets will be directly available for you to run the analysis. So these instructions are very, very straightforward. You can do it anytime. You can just run this. And also our exercise includes a small BWA deployment, Burrows-Wheeler alignment deployment as well. So you can run a quick alignment job in the cloud instances itself. Okay. Any questions? So we can jump on to the batch environment. Basically, it's a Genomics CLI. So you can click the workshop page on the left-hand side. So we have completed the S3, Amazon S3 storage. We have completed Amazon Elastic Compute Cloud. Basically, it's how you can deploy the compute instances in the cloud and how you can run the exercises and accessing the public data sets from AWS environment. Now we are moving to the Amazon Genomics CLI exercise. Basically, I already explained to you about what is the architecture of Amazon Genomics CLI. So you can skip to the next one. And this exercise we are going to run from a small Cloud9 environment. Basically, Cloud9 is another IDE. I really want you to give a second exposure of how you can share your workspaces with your collaborators. So the Cloud Shell is an exclusive space for you to run the analysis from the browser itself. Whereas the Cloud9, it is a shareable workspace. For example, if your team is going to modify the code or run the analysis, you can use the Cloud9. So how you can access the Cloud9? You can, the second page, under Amazon Genomics CLI, on the workshop page, under the left-hand side, there is Amazon Genomics CLI section. Under the Amazon Genomics CLI, there is a Cloud9 link. In the Cloud9 link, please click the first navigate to the Cloud9 console. There is a small link will be given. So I'm going to open it as a new tab. That is going to open up a Cloud9 console. Again, Cloud9 is a IDE. This IDE can be shared across your different group of your members. So we are going to do the Genomics CLI exercise from the Cloud9. I'm going to bring this Cloud Shell at the bottom now. Everyone is able to reach the Cloud9. Under the Amazon Genomics CLI section, you can see the Cloud9 recommended on the left-hand side. So click the Cloud9 recommended and click this Cloud9 console link under create Cloud9 instance. On the left-hand side, we are going to do this Amazon Genomics CLI exercise. Under the Amazon Genomics CLI, there is a Cloud9 recommended. Once you click the link, that will take you to this particular page. In this page, under the create Cloud9 instance, there is a Cloud9 console link. You just click that. That will take you to this particular page, Cloud9 console. Then click the create environment. There is a small orange color button here, create environment here. Create environment. Click that. Everyone is able to click it. Cloud9 console, then the create environment. And under this create environment, so you can just name your Cloud9 workspace. I'm going to name it as a workshop Cloud9. And I'm going to, basically this Cloud9 is going to run in a small EC2 instance. So this EC2 instance could be of any size. I would recommend to keep it as a T3 small or anything, but it's up to you to select any instance. If you wanted to take additional instance type, you can click and open it as a new additional instance. But for this exercise, T3 small will be sufficient because this is just going to be execution ground, but your actual running of compute analysis is going to happen in the batch compute environment. So these instances can be a bare minimal. You can select any instance type. And I'm going to leave the rest all it as a default, just create the environment. So click create environment and select the instance type, what you want to run the Cloud9, and just hit the create environment. So this particular workspace will be created for you, and you can execute all the analysis from here. But the real task execution is going to happen in the AWS batch compute environment. So you don't need to worry about the instance capacity. It can be any size, any minimal size, that is would be sufficient. So it is going to create this workspace. Any difficulties? Is it okay? It is going to take 1 or 2 minutes time, so now it's ready. So you can click open here, click the open. The Cloud9 is a very, very flexible workspace, and multiple people can operate at the same time. You can do a different task execution from here. And once this environment is created, click the open link. There is an open link. So click the open, and that will take you to this particular page. Basically, it's a small terminal page. It's a shareable workspace environment. So either you can execute all the tasks from the bottom, or you can click it as open as a new terminal. Next to the welcome page, there is a small plus mark. Click the plus mark and click the new terminal. There is a small plus mark next to the welcome page. Click the new terminal. If you click the plus, and that will give you different options. And I want you to click the new terminal. So the new terminal will open up here itself. Okay. I repeat again, a small plus mark will be next to your welcome screen. Click that, and then click new terminal. The second option, new terminal, that is going to take you to this particular shareable workspace environment. So here we are going to install Amazon Genomics CLI, which is nothing but the wrapper around the AWS batch compute environment. So Amazon Genomics CLI is going to create the batch scheduler, compute environment, job queues, and the necessary rules need to be deployed for running a genomic analysis. Okay. You can go back to this workshop exercise, and that workshop exercise might be having few lines of commands to deploy. So we have done this, Cloud9 terminal created. So we are going to move to the next page. The next page is going to instruct you how you can set up the Amazon Genomics CLI. You can click the 2 squares at the right-hand side. That is going to give you the commands, how you can copy that particular Genomics CLI, the package from the public repos to your Cloud9 environment. You are going to unpack and install. So these are the 3 lines of command. Basically, it is going to run. It is going to download that particular Genomics CLI, the installation packages. You are going to unzip it, and you are going to install it. So click the 2 squares at the right-hand side for this command, and paste it in the Cloud9 environment. Basically, okay. Click these 2 lines of commands here. Sorry, 3 lines of commands. You can just directly go and click the 2 squares at the right-hand side top. That will copy the whole chunk of command in that block and paste it in the Cloud9 terminal. So this is going to install now. We will finish it in 5-10 minutes time. Then we will go for the lunch. So in the meantime, I can explain some of the steps, what's happening inside. So once you have successfully deployed, and this AGC is installed in your local workspace, so you can just execute the commands from here, from the workspace to there. So you can easily check by executing the command AGC help, then it will show you the different. And then the second step, what you have to do is you can just run this AGC configure email. Basically, this configuring email to receive some notification about your workflow status, because you are going to submit a long-running job in the cloud environment. that job may be running for the next few hours. If you wanted to track the status, or if you wanted to receive the notification about your workflow status, that you will receive the notification about your workflow is completed or your workflow failed. If it is workflow failed, you can go back and look at the logs. You can easily debug your pipelines. So that is the reason why you're going to configure your email to receive the notification. And then you are going to set up some environment variable by running this AWS region submission. And these are the few things we have to do. Then next exercise, we are going to run a small RNA-seq pipeline, how we can deploy a RNA-seq Nextflow pipeline in the Amazon Genomics CLI environment, and how we can submit the jobs. So this is what we are going to do now. And yeah, once you have successfully installed, you should be able to get this help page command in your Cloud9 environment. If anyone facing any issues or challenges, please let us know. If you're getting any errors, anything. With this, we are going to adjourn for lunch, and yeah, please feel free to do the exercises, and we will continue during the Healthomics time as well. The second exercise part, we will continue from here. Any questions here? All good? Okay, thank you.
Oke, mari kita beri tepuk tangan untuk Bapak Edwin. Terima kasih atas paparan. Oke, baik. Untuk saat ini sesi workshop yang saat ini sudah selesai, dan nanti akan kita lanjutkan lagi untuk sesi kedua untuk workshopnya dengan tema Healthomics. Ya. Untuk saat ini kita akan memasuki waktu istirahat. Untuk makan siang sudah disediakan di depan, dan bagi yang ingin sholat zuhur itu berada di luar sebelah kiri. Nanti ketemu eskalator, di eskalator naik 1 kali di sebelah kanan, atau ada di lantai 5 ya, atau ada di lantai 5 seperti itu. Jadi kita akan berkumpul lagi di sini pukul 1.30 untuk sesi workshop selanjutnya yang Healthomics, yang tetap akan dipandu oleh Bapak Edwin. Okay.
So the next second phase of exercise is going to be the continuation of today in the AGC. Then we will move on to the Healthomics exercise. That is going to be like a fully managed service. More exciting, and yeah, look forward to seeing you in the afternoon as well.
Okay. Thank you. Selamat beristirahat. Kita akan berkumpul lagi di sini jam 1.30. Terima kasih. Selamat siang Bapak Ibu sekalian. Kita akan melanjutkan sesi selanjutnya dengan tema Health Omic Workshop yang akan dilanjutkan oleh Bapak Edwin. Oke, we can continue the workshop. Oke, terima kasih. Workshop akan segera dimulai. Bagi Bapak Ibu yang masih di luar, peserta AWS mungkin bisa langsung bergabung karena acara akan dilanjutkan. Terima kasih. Thank you.
Hello, everyone. I hope you have a great lunch. And can we continue the workshop here? Those who are new to this afternoon, probably you can follow this link. This link starts with a bit.ly/AWS_BGSi1 or 2. Either one of these things you can follow up. Some of you already might have tried the previous workshop and the continuation. So we continue from the Amazon Genomics CLI. We have deployed in our account, and now we are going to do run the exercises on top of the Amazon Genomics CLI. Again, I just would like to reiterate, Amazon Genomics CLI is nothing but a wrapper around the AWS batch compute environment. So if you'd like to submit the job to the managed scheduler, so AWS is a batch is one of the options in the AWS environment to run the compute analysis in a more scalable way. So some of the advantages of running in AWS batch is the dynamic provisioning of the compute servers for each of your tasks, and then you can run as many as parallel execution of your job inputs. For example, if you wanted to run 10 samples to run in parallel, you can submit the jobs, all the input data sets to AWS batch job queue. All the 10 jobs will be running in parallel. All the outputs will be kind of directed towards the output result folder. So if you wanted to run a parallel execution of multiple samples processing, AWS's batch is one of the way you can use for your managed scheduling the jobs. So let's continue from the exercise what we left in the morning. If you already closed this, your browser link, probably you can go and click the workshop landing page. And the workshop landing page, can you see this? I need to zoom a little bit. So in the workshop landing page, you may see there are two options. One is the AWS account access or open AWS console. Just you can open it as a new tab. That is going to open it as the AWS management console page. As I said before, whenever you get the AWS account, usually there are two ways to access the cloud environment. One is from the browser interface itself, and another one is you can just execute the task from the programmatic way. You can execute the API commands. Then these API commands will be invoked in the cloud environment. Today's most of the exercises we have done from the user interface, from the browser itself. So how you can access this management console, click the open AWS console. On the left-hand side, lower half of this will have two links. One is the AWS console. Please click it as open it as a new tab. You already have opened this particular AWS console. You don't need to repeat again. Your console might be appearing as a new tab here. Or if you're new or if you already closed this, please click from the workshop landing page on the left-hand side under AWS account access. Click the open AWS console. That opens up this AWS management console page. Excuse me. Okay, then you can type Cloud9. If your Cloud9 is not active, type Cloud9 at the top of the search panel. Type Cloud9. That is going to give us a top hit and open it as a new tab. Or if you don't want to access from the AWS management console, you can go to your workshop page. Under the instruction page at the top, under the Amazon Genomics CLI, there is a Cloud9 recommended link in the workshop landing page. Under the Amazon Genomics CLI, there is a Cloud9 recommended page. So you can just open it up. And you can click directly from here, the Cloud9 console. If you click this, it directly takes you to the Cloud9 console page. Either one of the ways. Either you can go from the management console, type Cloud9 in the search panel, and you can reach to the Cloud9 environment, or you can click the workshop instruction page. There is a Cloud9 recommended a link. In that page, actually, you can just click this Cloud9 console under the create Cloud9 instance, okay? So you might have created the Cloud9 environment. Just click the open up. Click this link, open link. That will open the page what you have already run, Amazon Genomics CLI. As I mentioned before, Cloud9 is the shareable integrated development environment workspace. Basically, you can execute the command, and also it has a lot of mechanism to share across your peer group members. So you can share with your colleagues, and they can modify the codes at the same time. So you all can parallelly work in this Cloud9 environment. So this is where we have deployed Amazon Genomics CLI, and we are going to create the AWS batch compute environment from the AGC commands, Amazon Genomics CLI commands. So I'm just waiting to this to be up. Then we are going to follow the exercises from here by running Amazon AGC Nextflow pipeline. So before that, we have to set some kind of environment variable. So please click Amazon Genomics CLI setup on the left-hand side. Amazon Genomics CLI setup. So in the morning, we have installed Amazon Genomics CLI. Now we are going to set some environment variables here. So my Cloud9 environment is ready. So I'm going to make it a little bigger. Hope you can see. No? Okay. So just to check your AGC deployment is right. So you can just type AGC space -- help. That should return all the help commands. So the first bunch of commands, we already executed it. Now we are going to the configure email command. Click the double squares at the right-hand side, configure email. You can just copy exactly the same and put it. There won't be any problem. If you really want to get some kind of a status update to be sent to your email ID, please put the right email address. Then you may get the status update from the right email address. So I'm just copying here and pasting into my environment, and I'm going to update the email address to my own email address. So you can do it for your case as well, whatever the email ID. You wanted to receive the notification of your email updates, and you will get it. And the next command is basically we have to set few environment variables here, like a AWS region. Mostly this will be US East 1 for this exercise. And so you can copy this bunch of command, activate account, and paste it in your Cloud9 environment. So when you activate the environment, what happens here is, it will take a few minutes actually. I can explain what is happening behind the scene. When you activate the account, AGC is going, Amazon Genomics CLI is going to create a virtual private cloud. Virtual private cloud means is, because cloud is a multi-tenant environment, so how you can isolate your own compute space. So this is where the concept of VPC comes in. Virtual private cloud means you are going to isolate your own compute environment within the multi-cloud environment. So you can just imagine, this is a big room. The whole room is kind of AWS cloud, and you are going to allocate your own compute space for your organization. Just you are going to make a partition, and within that partition area, you are going to keep your compute servers. This is the concept of the virtual private cloud. Virtual private cloud is an isolated space exclusively for you, and that partition area can be managed with the security groups, firewalls, security groups, and network access control list. Different ways you can just protect multiple layers of securities. You can just appoint them, and they will guard your compute servers, who can enter in or who can go out of the communications from your own server to the outside world. So this is exactly the same concept, virtual private cloud. Whenever you provision a compute server or compute instance under your account, you will be putting your compute server within the virtual private cloud. This virtual private cloud can be protected by the security groups. Security groups is kind of, you just imagine this is a kind of security guard is going to protect you 24/7 throughout the year, is going to manage it. So you are going to give some batches to the security group. He is going to check the batch, and he can allow the communication to your servers. Whether what kind of a protocol that can be accessed or it can be allowed into the compute environment, either a TCP protocol, either a HTTP protocol, that is going to be passed through your security guard. So it's exactly the same mechanism. When you are doing the AGC account activate, AGC is going to create your own virtual private cloud. Within that particular virtual private cloud, AGC is going to deploy multiple compute resources. It could be of one mission, or it could be of 1,000 missions, or it could be 100 missions. AGC is going to deploy within that particular compute environment. In addition to that, Amazon Genomics CLI, AGC, is also going to create a S3 bucket environment where the results are going to be uploaded or going to be synced from your computer environment. Once the data sets are processed, if you're running RNA-seq analysis, after processing your RNA-seq data set, where the results should be going into that particular bucket. At the same time, it could be of one sample, or it could be of multiple samples, 10 or 100 samples. All the processing will be happening in parallel. So the parallel execution is quite simplified in the Amazon Genomics CLI, and it is going to do the same thing. Now, this is what it is creating behind the scene. As I said in the morning, we operate in a concept called infrastructure as a code, because everything, all the deployment, creating a VPC, creating a S3 bucket, creating a security group, attaching a permission to the security group, everything we have written as a code. So this code can be reproducible, or it can be repeated in any environment. It could be in one hospital, or it could be multiple hospitals. You can just deploy the same code. It is going to deploy the same environment anywhere under your account. So it is going to take 2 to 3 minutes. Now, once it is set it up, we are going to run the next line of commands here. Any questions on the Amazon Genomics CLI setup? And also, I would like to emphasize here, if you don't want Amazon Genomics CLI to create a new VPC, you wanted to deploy it in your existing VPC. Some of the organizations, they may prefer that way. They might have already prepared a VPC, and they might have created the S3 bucket. You can just point that VPC to be used for the Amazon Genomics CLI execution. Just you need to attach a small tag after the activate button, --VPC, and you can just specify this VPC ID to be used for the Amazon Genomics CLI workloads. So AGC is going to use that particular VPC. Similarly, if you wanted to not to create a one S3 bucket for Amazon Genomics CLI, you can just attach additional tag after the AGC account activate. Use this S3 bucket for Amazon Genomics CLI results to be copied, or it can be stored there. So these are the few mechanisms, few ways you can activate your account. And this will be used, this will be the first step you have to do. So the next step, actually, what we are going to do is, this is the workflow architecture, what happens here. As I mentioned in the morning, Amazon Genomics CLI is going to rely on one of those workflows engine architecture. It could be of an Nextflow engine, or it could be of a Viddle engine, or it could be of a SnakeMake or Chromewell engine. Either one of those engines will be used to receive that workflow definition at each of those steps. So Nextflow engine systematically issue the commands to the Amazon Genomics CLI environment to execute the task. So within this Amazon Genomics CLI environment, the compute context will be automatically created. The compute context is part of the AWS batch environment. It includes the compute environment, it includes a job queue, it includes the workflow definition. So all these instructions, all the processes, what happens in each of those steps is given in this workflows page. Please go through at your time, at your own pace. And please reach out to us if you have any questions here. So now it is done. Most of you might have reached this particular stage. Once you have done the activation, this AGC might have created a VPC. It has created a S3 bucket. The next step we can follow from here. We can create a small Nextflow projects. So you just copy this command. If you go to your environment, and you should be able to see there is a small Amazon Genomics CLI folder might have been deployed, might have been installed under your account environment. For those who can't see it, I can make the text a little more bigger. The font size, okay. Just make it as a bigger one. How about now? So big? Just make it so. I hope you can see now. So you may see Amazon Genomics CLI is already created. Within that Amazon Genomics CLI, there are a lot of different templates that are available. We have created an Nextflow template, we have created a SnakeMake template. So as an end user, you are free to use or modify the existing Nextflow template suitable for your own pipeline. So now what we are going to do is we are going to get into that particular Nextflow template folder. CD Amazon, just copy this command and go inside and paste it here. So you will be getting into this particular folder within the Amazon Genomics CLI. There is a subfolder examples and demo Nextflow projects. And we have a number of different templates available here. So if you wanted to check the context and the workflows, you can easily look at here. I can quickly show you one of those contexts inside the Nextflow project folder. So every Amazon Genomics CLI workflow includes these three different steps, and so it is smaller. So you could see first compartment is mainly talking about the different workflows. It could be for RNA-seq workflow, or it could be for Hello World workflow. This is the first compartment. And the second compartment is a data block. The data block is mainly useful whenever if you wanted to create a new input data bucket access, you have to mention in this particular data block. In AWS, we operate in a concept called policy permission. So even though you are the service under your own account, you have to explicitly attach the permission to that service. Then only the concerned service can talk to other service. Here, Amazon Genomics CLI is related to the AWS batch service. So you have to explicitly provide the permission to the AWS batch to talk to S3 and fetch the data set from the S3 bucket. So that is why we are attaching this particular data block. This data block, once it is specified in your configuration file, YAML file, this particular S3 bucket will be granted access for the batch to extract the data set and run the analysis. So this is a data block is important. And the last one is a context. The context, you can define a cluster of compute instances. So what type of instances to be used for running the analysis? You can give a CPU instances or AMD instances. You can give a mix of different instances. We will be doing one exercises on how to create the context and how you can construct your own compute fleet of instances. And the last block is about the engines, which engine you want to use, Nextflow engine or Viddle or mini Viddle engine, which engine you wanted to use. And at the same time, you also have the flexibility to use the spot instances. The spot instances in one of the way you can optimize your cost. Spot instances are nothing but AWS gives the spare capacity of compute instances at a very, very discounted price. In the morning, a lot of banking sectors and other companies might be accessing our compute servers. So the compute servers will be fully busy, fully utilized in the particular region. In the evening time, after office hours, the compute instances may be coming as a spare capacity. A lot of compute instances might be available within that particular Jakarta region. So AWS tend to give those spare capacity of compute instances at a very, very discounted prices. For example, if you're paying a C5 X large, $1 per hour, if you're opting for the spot instances, the evening hours, if you're running a workflow in the evening, the spare capacity will be given you for 50 cents or something. So you will get the 50% cost savings at each of those compute usage level. So the spot instance is one of the effective way you can kind of cut down your compute cost significantly. So if you enable this particular request spot instances and your workflow is a fault tolerant workflow, because what happens in the spot instances is if the spot instances are needed for kind of in the on-demand user group, the spot instance will be immediately cut off, immediately kind of your job will be interrupted with a 2 minutes of notice, and the spot instance will be taken off. So what you have to do is you have to cache your outputs in a periodical way. Actually, every 5 minutes the caching need to be done, or every 2 minutes the caching need to be done. At any point of time, the spot instances cut off your job. Your job should be able to resumable when the instances are available to you at the back. Okay, so the spot instance, one of the way is a very useful way if you wanted to optimize your cost, and the first prerequisite to use the spot instances is your workflow has to be a fault tolerant workflow. Nextflow does have the option to resume where it got interrupted, but other engines you have to manually kind of deploy certain caching mechanism and you can resume it. If you set up that particular resume mechanism, spot instance is the best way to go to optimize your compute cost. So these are the few ways you have to construct this particular YAML configuration file. Once this YAML configuration is constructed, you should be able to check what are the different contexts available, or what are the workflows available here by running these few commands. So you just run this AGC context list that is going to list what are the different contexts you set it up within your environment. So I'm going to just quickly check running these two things. Should be aligned quite close to the YAML configuration file. We do have a both on-demand context as well as the spot context is defined in this AGC project YAML. And the workflows, actually, we have 3 different workflows in the YAML configuration that is exactly displaying here. The hello workflow and RNA-seq workflow. Can you see here? This hello workflow and the RNA-seq workflow and the words workflow. These are the 3 workflows are kind of built in the YAML configuration. That is going to be displayed here. These are the workflows that are available for you to run. Okay, and we are moving on to the next step. And this is the one of the NF core RNA-seq. Yeah, please. Agus, you could not able to? Region is not set it up. So this is one of the RNA-seq workflow publicly available in the GitHub repos. So let's try to deploy this RNA-seq workflow and run one compute analysis inside this environment. Okay. So we do have a few lines of command. I can explain these commands what it does. You can directly copy and paste it, but we are going to go back to the home directory, environment directory, and we are going to create a small folder called RNA-seq folder. And then we are getting into that particular RNA-seq folder. And this command, AGC project init, with the name of RNA-seq, it is going to create the template of AGC project YAML configuration file. Okay, so this YAML configuration file is essential for every AGC workflow. So you copy the whole bunch of commands here and paste it in your environment. Okay, so you are creating an RNA-seq directory, and after you get into the RNA-seq directory, you are going to make it as a project init command that is going to create a Nextflow compatible templates inside the RNA-seq folder. So if you wanted to ls it, that will show you this AGC project YAML is already constructed for you. So you can modify, you can tune it a little bit. It comes to the basic template. It is going to create all the necessary blocks like a data block or a workflow block and the engine block. Everything will be there. And this is what I was referring to, the AGC project YAML file, which I'm going to modify. Because if you open the existing one with the project init button, that's execution step. I can quickly show you. That might be with a very, very basic template here, but we need to modify this basic template. That's what I'm going to do. In the next step, if you go to the workshop page, there will be a AGC project YAML file under the project configuration step. Left-hand side, under the Amazon Genomics CLI setup, there is a project configurations link. If you click it, you might have done the previous one. And now you are going to copy the whole bunch of command with a cat command. So I'm going to create a workflow called RNA-seq workflow, and what type of engine I want to use it, and what are the different data set need to be given the permission. So I have given the permission to access the 1000 genome project and NF Core AWS Mega Test Dataset bucket, and also the NGI iGenomes bucket. If you have your own input data sets need to be accessed, you have to add additional line, these 2 lines, location and the read only as a true. For example, if you're going to access your own input dataset folder, you have to add this before executing the context. Whenever you have a new dataset coming to the new bucket, this data block need to be updated and you have to redeploy the context. Okay? So first block is about the workflow. Second block is about the data set. What are the input data sets to be accessed? And the third block, this is what I was talking about. You are defining your compute instances. So for this RNA-seq workflow, I have given the 3 different family of instances. The first family is about the Intel family, C5 servers here. And the M5 is a good mix of both Intel and the AMD. And the R5 family is mostly AMD processors, like very, very memory intensive. Memory intensive means it might have a 2 CPU machine, but the RAM might be like a 46 GB RAM memory. So these instances, depending upon your workflow definition, your workflow SAM indexing job requires a 2 CPU and 32 GB RAM. The R5 instances will be picked up by the AWS batch and the task will be executed in that particular instance. So copy this whole bunch of command here, the whole block of command, by just clicking the double squares on the right hand side, paste it in your Cloud9 environment, enter. So this particular AGC project YAML file might have been updated. So I repeat again. So copy the whole block of commands here, AGC project YAML, right from the cat until the end UIF. So we are just updating the AGC project YAML configuration file to run the RNA-seq pipeline. Okay, once you have done it, this particular project YAML file has been created. The next step is you are going to create a manifest.json file. Manifest.json file is very, very important when you have your new workflows to be updated. It could be of a public workflow from the NF Core repo, or it could be of your own custom pipeline workflow. So you just need, now this particular pipeline is going to rely on from the public RNA-seq pipeline. So that is why this main workflow URL specifies to point the GitHub repos of RNA-seq, NF Core RNA-seq. If you have your own workflow, you just put that particular workflow folder, including all the dependencies and the sub workflows. You can point your local path as well. And the second option is engine option, which Nextflow engine to be, which version of this particular workflow to be used. Because NF Core might be updating a different version of RNA-seq pipeline. For this exercise, we are going to use a 3.5 version of RNA-seq pipeline. That is what we are going to run. So copy the whole block of commands by clicking the double square and paste it there. And this file might have been created, the manifest.json file might have been created. So for every run of your pipeline, you have to have manifest.json file and the AGC project YAML file need to be created for you to run, or for you to run the AWS batch compute environment. So now you can see, if you ls it, inside this RNA-seq, these 2 files have been created. AGC project YAML file, and the manifest.json file has been created. Everyone is at the same page? 2 files have been created under your RNA-seq folder. So we have given step-by-step instructions as well. If you wanted to run a full exercise, full data set, because this is now this particular AGC pipeline is going to run the test data set. If you wanted to run a full data set, you can click this particular optional exercise. You can do it at later. This optional exercise includes inputs.json. In addition to manifest.json, AGC project YAML file, you can add your inputs.json. Inputs.json is going to define where your input data sets are going to be. And that data set can be used from by here. It could, because we are going to fetch the input data set link from the public NF core link, but you can have your own CSV file as well. If you have your own CSV file, you can just point / your sample sheet.csv. So it is going to fetch the sample sheet from your local path, and it is going to run this analysis. So whenever you wanted to update a new input data sets, you can do it, but we are not going to do this optional exercise. Once you have created the manifest.json and the AGC project YAML file, you can move on to the next step and run this command called AGC context deploy RNA big mem. The context is nothing but basically, as I mentioned before, can you see this? The context RNA big mem, which I specified at the top. The RNA big mem context defines the group of compute instances. So once you deploy that command, AGC context deploy RNA big mem context, it is going to create the compute environment in the job queue for you to execute the your workflow pipeline. Okay. So copy this command, AGC context deploy RNA big mem, and paste it here. So it is going to create the compute environment in the job queue under your batch scheduler environment. Okay. It's going to take another 5 minutes, but we are going to do a different exercise in the meantime. So everyone is able to execute this context deployment. So in the meantime, the context deployment is happening. We are going to do some healthomics exercise now. So we can cover both services training now. Okay, everyone is able to deploy the context. Any issues, please let us know. August is here and he should be able to fix it. Okay, so go to your cloud console, management console page, this page, and type omics at the top of the search panel here. At the top of the search panel, type omics here. So that will take the different hit lists as AWS Health Omics at the top. Click the link. So that takes you to the Health Omics console page. On the AWS management console page, at the top of the search panel, type omics, O-M-I-C-S, omics, and the top search list will be giving you as AWS Health Omics. Click that AWS Health Omics. That will take you to the AWS Health Omics console. On the left-hand side top, there is a 3 lines, the burger icon will be there. Just click that. On the left-hand side top, is it visible? Yeah. On the left-hand side top, there is a 3 lines. Just click it to unpack what are the different modules that are available in the AWS Health Omics. Before that, I would like to quickly show you this particular slide to give you some understanding about AWS Health Omics. Basically, we have launched this AWS Healthomics during 2023 after we had worked with Genomics England and UK Biobank and a couple of other large-scale projects. We learned some of the challenges on the genomics data management. So to solve those challenges, we tried to make this purpose-built service. By nature, AWS tried to offer the building blocks. Whenever the particular requirement needs a complete solution, we try to advocate our partners to deliver those complete solution. And in addition to that, we are trying to give a small Lego block, which is kind of a tailor for making the genomics is more compatible. So AWS Healthomics is one of those Lego building blocks that can give you kind of an additional purpose-built service tailored for the genomics data management. This includes 3 different modules. The first module is about the storage. So how you can organize your reference sequences or your input genomic sequences in the Healthomics storage module. So there are 2 different stores. We operate in a concept called the stores. The 2 stores, one is a reference store where you can manage all of your reference sequences. It could be of a human genome, 19, GRCH, 38 version, 37 version. In this sequence, this reference store, you can catalog all the different model organisms or all the human organisms reference sequences. And the second one is about the omics sequence store. Omics sequence store is mainly to manage your FASTQ, BAM, or CRAM files. Basically, this omics sequence store comes with a few advantages. This is a genomic-aware data storage. As we mentioned in the morning, S3 is an object store. S3 doesn't care what type of data sets you are storing in that particular S3 bucket environment. Whereas in the genomics sequence store, it is a genomic-aware data storage. Whenever you import a FASTQ file, it recognizes and it estimates the number of bases available in that particular FASTQ file. Then it is going to charge based on the number of bases. Instead of gigabytes or megabytes, Healthomics sequence store operate in a concept called number of bases what you're going to store. This will be very important because sometimes the researchers tend to generate the high coverage genome sequences, and the basis-based concept of pricing will give you a lot of advantages. In addition to that, sequence store applies a lossless compression on top of your input data sets. So you will get a significant cost benefit from there as well. And sequence store also compliant to the GDPR regulatory compliance standards. If you're going for some FDA approval or some kind of international standard approval, you can easily comply to those standards. Because whenever the data sets are imported into the omics sequence store, the objects becomes immutable. And in addition to that, each of those FASTQ read file or FASTQ BAM files need to be attached to the multiple metadata informations, like which hospital or what type of technology that particular data sets are coming from, Illumina, Oxford Nanopore, PacBio, what other technology are being used to generate the data set. And also you can pack as much as metadata information, like a hospital, age group of that particular FASTQ file coming, the data generated from. This will be very important because you are packaging lots and lots of metadata information. When you grow up multiple samples and thousands of samples, at some point of time, you may have an opportunity to share a subset of data set. This kind of a metadata information will be very useful. You can easily make those subset bundles when you do these kind of best practices in the omics sequence store. Today, we will be focusing only on the omics workflows. Omics workflows is kind of a lot of best practices, what we followed in other large-scale projects. 2 major prerequisites to run your pipeline in the omics workflow environment. The first requirement, we try to recommend orchestrate your workflow. Healthomics accepts 3 orchestrated workflow: Nextflow, WDL, and CWL workflow. This is the major requirement to run the pipeline inside the Healthomics workflow environment. The second requirement, your software tools need to be containerized and packaged in as a Docker images into the AWS ECR environment. This will help you to run a large-scale analysis, because if you are relying on the Docker from the public repos, often you may hit the throttling. If you are going to access those Docker images for 100 sample parallel analysis, you will easily hit a throttle. So always we recommend to bring your own Docker images into your own container. That gives you the scaling mechanism of running your pipeline. So these are the two major mechanisms for running your workflow into this particular environment. Rest of the things, everything happen under the hood behind the scenes. So you can submit any number of samples. It could be of 100 samples or it could be of 1,000 samples. Everything goes in parallel. There is no limitations. And if you're going more than 1,000 samples in parallel, you can always increase your limit of concurrent tasks. So this makes you the life easier. You don't need to create a computer environment, job queue, or anything. Orchestrate your workflow, containerize your software tool, push your workflow as a zip folder. That will be accepted by the Healthomics. Basically, it runs certain integrity checks or dependency checks and everything. Once it is accepted and your workflow becomes active, you can submit any number of sample analysis to the workflow environment. The last part is about analytics store. Analytics store mainly for the population sequencing data integration. If you're generating a numbers and numbers of VCF file, and if you wanted to make it as a structured database schemas, this analytics store will be very, very handy to run it. Basically, you don't need to worry about how you can construct your database schemas. As long as you have your VCF file, you start pushing into this variant store, it automatically creates the merged cohort level database schemas for you. So you have the flexibility to change the default schemas, but at the moment, most of those VCF standard formats can be accepted, and it can automatically transform all the VCF and GFF files into the structured schemas. And these schemas will be directly available for the end users to run the query from the lake formation, and they can run a simple SQL query to extract the biomarker at the cohort level or at the individual level. They can just join multiple data sets, VCF files of cohort with the annotation file like a CleanVar or Genome annotations, and combine with the clinical data set, demographic data sets, everything. So you can easily get the output by running a simple query languages, and you can extract the insights and the biomarkers. So these are the different functionality features of Healthomics, but today we just operate only the Healthomics, how you can execute a pipeline in the Healthomics workflow environment. Any questions on the Healthomics concepts? Okay, so skip this and we can go to the Healthomics page. And I'm going to show you a few things. The Healthomics has two important workflows. I missed it. So in the Healthomics page, if you scroll down on the left-hand side, there are under the workflow section, you can see a ready-to-run workflows and a private workflow. Healthomics does give you the option to run our pre-packaged workflows. Pre-packaged workflow means what are the pipelines that have been frequently asked by our researchers and the end customer. We try to update these pipelines like a GATK best practices or NVIDIA Parabricks pipeline or a Sentient long-read pipeline. These are the pipelines we already pre-packaged, containerized, and orchestrated in appropriate languages. That is kind of a ready to fire. Basically, you can just bring your input data set, select the pipeline, what you want to run, and point your input data sets. You can just click the start run, that automatically process it. It also allows you to scale it. So if you wanted to deep dive into this ready to run workflows, please click on the left-hand side of your Healthomics console. There is a ready to run workflows page. If you scroll down, and you should be able to see 36 ready to run workflows, which will be listed in this particular page. This includes both genomics pipeline, Illumina short read, long read, PacBios, YNT pipeline. In addition to that, if you have interest on the protein folding, you can use this AlphaFold or ESM3 folding analysis as well. This comes with a very transparent policies. If you scroll left to right, you should be able to see the list price per run per sample and also the estimated turnaround time to run this particular execution. For example, if you wanted to run a small NVIDIA Parabricks pipeline or a GATK best practices germline pipeline, and you wanted to understand what happens, we didn't make it as a block box for you. If you click this GATK best practices germline, FASTQ to VCF file for the 30x genome coverage, it will open up here, and it will tell you what are the different versions of the tools that have been used in this particular pipeline, like a GATK 4.2.61, SAM tools 1.16, and on top of this, you should be able to see the whole processes happens in the workflow diagram. So this illustration will give you the detailed explanation of what are the different processes happens when you input a specific input the FASTQ files inside, and it gives you all the concepts of running the whole pipeline. Finally, the GVCF files will be generated out of the GATK best practices, and these files will be directly available for you in the S3 output buckets. Okay, and the same thing actually you can see if you want to run a long read pipeline or NVIDIA Parabricks GPU based pipeline. This gives you the detailed picture about the price per run and the turnaround time of completing the analysis here. And if you have a specific interest to run the PacBio pipeline or ONT pipeline, we do have our partners. They have already optimized the long read pipeline. Basically, if you want to run a Sention long read Oxford Nanopore pipeline, the meeting happens in the next door. The pipeline cost about $1.78, and it is going to take about 1.5 hours to run it, because Sention uses their own proprietary engine. That engine is mathematically optimized semiconductor principle, so it can get the acceleration from the mathematically optimized algorithm, so they can run it pretty faster. So only one caveat I would like to point here, and it's not caveat, basically it is a license costing. Sention has a separate license mechanism. So as an end user from the hospitals, the pharmaceutical company, or an individual research organization, you can talk to Sention and get the licensing costs sorted. Then your account will be whitelisted. Once it is whitelisted, you should be able to run the analysis using the Sention platform. And the second part is ready to run workflow, and then private workflow. The private workflow, basically, it allows you to bring your own customized pipeline. As long as you have orchestrated in an Nextflow or a WDL or CWL, then you should be able to bring your own workflows and pipeline here as a private workflow. And this costing is based on the consumption base. Your pipeline is running for 1 hour. There is what are the different compute instances are used for that particular pipeline. According to that, it is like a pay-as-you-go based pricing. How many instances you are using and how many hours you are running the pipeline inside the private workflow. According to that, you will be charged. So with this Healthomics introduction, probably we might have completed the context activation step. Everybody got the activation context, the AGC? Done? So I'm going to explain a few things on the context, what happens behind the scene and when you executed this command. So go back to your management console and type batch at the search panel. On the top of the search panel, type batch here. And click the batch. That will take you to the batch console. I again repeat, on the top of the search panel, type BATCH, batch. So it will take you to this particular dashboard page. And left-hand side, click the compute environment here. Left-hand side, there is a compute environment page here. Compute environments, yeah. Click that. So that will give you, basically, this compute environment was created by Amazon Genomics CLI for you, based on the RNA-seq context which you have deployed. So every time when you deployed a new context, this compute environment will be created for you to run the analysis. There are two things might have been created on the context deploy step. One is the compute environment step, and another one is a job queues. This job queue might have been created for you to run the RNA-seq analysis. So you can submit your job, all the RNA-seq jobs into this job queue. All the tasks will be going in the parallel in a kind of more automated way. Okay? So this is what I was referring to, is how you can run the batch analysis. One way, you can directly create the compute environment, job queues, and job definition by yourself. If you're familiar with the AWS batch, that is perfect. If you are new to this AWS batch or HPC environment, you can rely on the Amazon Genomics CLI. you let the Amazon Genomics CLI to create the compute environment and the job queue for you. You can directly submit the jobs in there. Okay, that is what it happens. So once you deploy the context, these are the two things might have been created in the AWS batch environment. So we have created, we deployed the context. Now we are going to run this particular workflow. So this particular command, AGC workflow run RNA-seq, basically the once you specify this RNA-seq workflow, the AGC is going to look for what is the inputs data sets you are pointing. In this case, our manifest.json file is pointing at test data sets. We already specified you need to run this test profiles. If you have your own input data set, your manifest.json should include an additional line, the inputs data.json. The input.json can define your input data file path, your RNA-seq forward read and reverse read path, then it is going to run. So once you executed this command, AGC workflow run RNA-seq, it is going to look for your manifest.json. Manifest.json will give all the parameter values to run. So please copy this command and execute in here. Enter. So your workflow starts begin. Your job is submitted to that particular RNA-seq job queue. Once the job is completed, you will see from the AWS batch compute environment, job succeeded. You can go back to the S3 bucket. Inside the AGC folder of your S3 bucket, that will have all the results of your RNA-seq quantification summary here. Inside. Okay, so you can close this Cloud9 at any point of time. All the workflows might have been running at the background in the cloud. So you can close your workstation, still the workflow ID. You can easily track your workflow status by using this particular ID. B13, there's a long string of letters might have been given, and you can get this ID anytime. We have a few comments to extract what are the current active processes running in the AGC environment. So this is a quick way how you can run your workloads, pipelines from the public repos or your own repo, own pipelines. It can be runnable in the AGC Amazon Genomics CLI environment. As long as your workflow is orchestrated in one of those languages, Nextflow, CWL, WDL, or SnakeMake, you should be able to run the pipeline using AGC. And yeah, this is the first exercise on the batch compute workflow. And please feel free to this workshop link will be available for you any point of time if you wanted to cross-refer, and you can execute this. Or and also this cloud user account will be available for you for the next 2 days again. And you can use this cloud account for you to test your pipeline analysis. So I'm going to shift to the Healthomics. If you have any queries or any doubt on the Amazon Genomics CLI, please let us know. Okay. I'm just quickly point some of the exercise here, some of the possible options you can explore later. Once you have submitted the workflow, that workflow might be running. And if you wanted to check the status of your workflow, you can just run this command, AGC workflow status, and it will show you like initializing, running, completed. You can test it even now. That's you can just run this particular AGC workflow status command. That will give you what is the current active workflow run ID, along with that what is the status of the current workflow. You will get those information. And if you wanted to extract the logs, task logs of your pipeline, you can run this command, AGC logs engine -- context, and providing that particular run ID, that is going to give you the different task process, because your RNA-seq pipeline might be including number of different tasks, and you will get the whole process of the different tasks, which task is completed, what is the current task is running in the AWS batch environment. So these are the few ways you can track your workflows and pipelines running in the AWS batch environment. And also I have given few additional input, like how you can modify your configuration YAML file. If you have your own input data sets, you can just add these 2 lines, the location of your own input data set. If you have a new input data set, you have to modify in your AGC project YAML configuration file, S3 / your bucket, and what is the prefix subset folder of your bucket. So this can be modified. Whenever you have done the modification in the AGC project YAML file, you have to redeploy the context. Don't forget, if you have your own input data sets need to be pointed for running analysis, you modify YAML configuration file and redeploy by running this particular command AGC context deploy with that specific context. So AGC try to establish the policies and permission to access that particular specific input data buckets. So this is very, very essential. Otherwise, you will get an error. Your input is not accessible, or we don't have permission to connect to the S3 input. Okay. And yeah, we have given few additional commands as well, how you can monitor in a different way. So it gives you a very, very fine-grained access or track your processes with the AGC. So with that, yeah, we are finishing up on the batch workflow execution on AWS environment using Amazon Genomics CLI. We are going to do a 2 exercise on the Healthomics workflows. Any questions? No? We'll go to the Healthomics now. So you might have already opened the Healthomics page here. So today we'll run a GATK best practices germline variant calling pipeline for the FastQ to VCF. So if you scroll down in the ready to run, you click the ready to run workflows on the left hand side. Once you reach the Omics page, type Omics on the management console. That will give you the list of different Omics related services. So click AWS Healthomics and then click on the left hand side top, these 3 lines. That will unpack and all the available modules in the Healthomics environment. And then click ready to run workflows under the workflow section. And then you scroll down all the way, and there is a pipeline called GATK-BP germline FQ to VCF. GATK- this particular pipeline. That is what, but you are free to use any pipeline, but I'm going to follow today for this particular pipeline. GATK best practices germline FastQ to VCF, which is FQ to VCF for 30x genome coverage pipeline. Just click that pipeline here. Okay, so once you click this particular pipeline, that page will open up. That includes the create, run, and everything. But we need to download some input test data sets. It's just a parameter files. It is not going to download anything, big files to your laptop. So how to view this? Can you see this? There is a link called workflow files, view, test, and example parameter files. If you already opened this GATK best practices germline FQ2F, there is a details section here. Under the details section, there is a option for workflow files. Please click the view, test, and example parameter files. Here, view, test, and example parameter files. And it will take you to a S3 bucket. This, when you click this view, test, and example parameter files, it will take you to the S3 bucket. In this S3 bucket, if you scroll all the way down, there is a parameters.json file. Can you see this? After you have reached an S3 bucket, view, test, and example parameter files, once you clicked it, that will take you to a specific S3 bucket link. Then inside the S3 bucket, if you scroll all the way down, there is a parameters.json file. Please click that and download that parameters.json file. Please click the parameters.json file. And there is an option called download at the top. Download the particular file. So it will download a small JSON file in your laptop. And I open up with the VS Code. Okay, one thing you have to make a change here. Actually, by default, it should have been made. There is a region need to be updated here. Can you see this? This is a particular region is not updated. Basically, I want you to replace this particular region to US-East-1. This particular region need to be updated with US-East-1, because this particular input data set include multiple rate groups. You don't need to have all these things. If you wanted to delete it, you can delete other rate groups. I'm just going to keep only one rate group. This colon cancer file includes a multiple rate group. So I'm just going to keep only one rate group. I'm deleting all other rate groups. So don't forget to delete the comma as well after the first rate group if you're deleting. Just save this file. Open this parameter.json with any of your text editor. And I want you to replace only the region portion to US-East-1 and delete all the rest of the rate groups if you don't want to run the multiple rate groups. So that's it. You can save this file. Everybody has done it. So only one change in this particular JSON file. Once you have downloaded it, you need to modify this region file. That's it. Okay. Any doubts? Anybody? No? Once you have downloaded and modify it, can you go to this ready to run workflows and click create run. Click create run and name the name, whatever the name you wanted to call it as. I'm going to run GATK best practices test. And you may get to the option like a select S3 output destination. So you can just click browse S3. So that will take you to your own S3 bucket. This means where your output need to be placed after it processed your colon cancer FASTQ data sets like a VCF, BAM, and other files need to be deposited in a specific bucket. So it is asking for where I should put your output files. So you can just click browse S3. And you can select your own bucket, the bucket you have created in the morning. It's up to you, or you can select any of your bucket. Okay. So the third section where the output files need to be synced. So you can click the browse S3 button, browse S3, and it is going to open up a S3 buckets page of your account. Then you can point where you want to put your output files in that particular bucket. And everyone is done pointing the output bucket. Then the third important component here is the service role. As I mentioned before, in AWS, every service has to be explicitly given a permission to connect to other services. Although everything is under your own account. S3 is a different service, EC2 is a different service, Genomics is a different service. You have to, everybody is treated as an individual user in AWS. So you can just treat them as external user. You have to specifically mention this Genomics can be connected or communicated to a S3 or kind of a compute instances. So this service need to be explicitly given a permission. So this role has been already created. So you can directly click this service role name. And usually these permissions are given in AWS by a service called IAM, Identity Access Management Service. IAM comes with the policies and the roles. Policies means you are defining Healthomics can talk to S3, Healthomics can talk to container repository, Healthomics can talk to some other services like a lake formation. So we are giving permission at each level, and this permission will be invoked. Once it is invoked, that will be bundled as a role, and that role need to be attached to for your pipeline. So that is what we have done. We already created this Omics unified job role for you for this workshop. But when you actually run your pipeline or if you are creating a role, you have to follow the guidelines. We can give you some kind of a script that can automatically create those policies relevant or required for running this Healthomics workflow. Okay, this role need to be definitely attached, otherwise you may get up an error. So what we have done is, we have clicked the create run, we have named that run, and we have pointed where my output files need to be stored, and I'm attaching a role to give the permission for Healthomics. That's it. You can click to next. And there will be a parameter values file. What we have done, we have pointed the output bucket and attached the role. Now we have to give the input values, which input dataset should be running. So that comes in the section of add run parameter values. So there are a few options. You can point the JSON file, the input value file, the colon cancer input datasets, right? That can be in S3 bucket input datasets path, or it can be local, because now we have downloaded and modified the JSON file. So that's why we are pointing a select JSON from local. Once you enable this radio button, that will take you to the next function like a choose file. So please select JSON from local. This means you are going to give the input parameter values. Your input parameter values comes as a JSON. That JSON includes the S3 input path, just that's it. So whenever you get a new data sets, you just modify the input data sets and you point that input data file. In my case, this is the parameters.json file, which includes the colon cancer FASTQ data sets. And choose file, click JSON, select JSON from local, and then scroll down. There is a choose file option, and choose file. That file should be the file which you downloaded and modified your colon cancer data sets. Okay, that's it. Then you click next. Everybody is on the same page. So click next. So the last page is just to review and run. You can just go through the review button, and that's it. We can go to run. Click the start run button. And once you click the start run, that will show your top blue ribbon preparing to start running the jobs. Okay. Everybody is able to run this ready to run pipeline. Any questions or just stuck? Okay. So I'm going to point few more things here. Once you executed the run in the Healthomics environment, how you can track your task processes. So this task process is currently running, and it's just starting now, so I don't have the visibility to. Okay. So once the task is currently running, so you can go to the runs page on the left-hand side under the workflow section, and if you click it, and this includes the different table column values. Actually, first value, it is going to show the different tasks consumption. So Healthomics is kind of extremely transparent. So you will get the visibility of what compute resources are being used in each of those task level, and how much memory was used, and how long that particular task has run from this particular dashboard. You should be able to completely get the whole picture. Once you click the runs, once the runs have completed, click that particular runs page, that will open up a table, and that table includes the CloudWatch logs link. The CloudWatch logs link provides what is the task process execution status at this point of time, and then it also shows how long that particular task is completed, how many CPUs, how many memory was used to complete those analysis. So the complete picture you will be getting here, and also the top, you will be getting the output file, where your output files of that particular run is stored now. And also you should be able to view the whole engine log. Some of the people wanted to debug their Nextflow or workflow engine files, so you can directly click the run logs. That is going to give you the engine logs as well. So you can easily trace back or optimize the compute resources. So these are the few ways you can get it. If you are running this is about ready to run workflow. Ready to run workflow always comes with a fixed pricing to what are the data sets you are running. It is going to be $7 or $8, $10. That is a fixed pricing. If you have your own pipeline, or if you wanted to modify the existing ready-to pipeline, even though it is a GATK best practices, today you may be running a whole genome sequencing, tomorrow you may be running a whole exome sequencing. I wanted to get a variable pricing for my data sets. You can just package that particular pipeline, GATK best practices, as a private workflow. So it is like a pay-as-you-go based pricing. So depending upon your coverage and actual run of your pipeline, you will be charged. How you can track those kind of a cost? After every successful run, we do have some kind of a scripts which is already pre-packaged for you. You can go to Google and type omics-tools. That will take you to this particular GitHub repos. Omics-tools. Is it visible? Okay. At the top, what you can just search for omics-tools. That will take you to this particular GitHub repos, which we already prepared, all the wrapper scripts and everything inside. You can just deploy directly from PIP as well, Python installing packages, and that gives you the different functionalities. One functionality is the Healthomics tools that is going to give you the compute resources. For example, if you have defined your workflow task with a certain number of CPUs, like 35 CPUs for a alignment job, but actual utilization may not be 35 CPU for your data sets. It might be less than 25 or 26 CPU. How you can optimize it? Once you have completed your Healthomics run, then this particular omics tool can give you the tracker, basically how much compute resources was utilized for each of those tasks. Instead of 35 CPU, you can slash down to 24 CPU for your next run, so that you can easily optimize the cost. And this is the first benefit of using this omics tools. Once you installed it, and there is no charge. It's an open source scripts we have created to track the compute resources utility. And also you can get the costing as well. If you wanted to charge back your clients, for example, some of the companies, they wanted to charge back their clients for each of those sample runs, they can get the visibility after completing each run. So you can run a small line of commands like omics tools and costing with that particular run ID. That is going to give the total aggregated cost for completing that particular sample. So you can easily charge back your collaborators or your other clients based on that particular costing information coming from. And as I mentioned, you can easily optimize your workflows as well based on the utility, and you can easily slash down or modify your existing workflow codes for the compute resource requirements. So I'm strongly encouraged to use these SDK tools which we have prepared. And these tools not only kind of helping you to optimize your workflow and tracking your costs. In addition to that, there are a lot of transfer manager, how you wanted to transfer your data sets to the omics environment. So the last point I would like to touch upon, everybody is able to run this private workflow. The last point I would like to touch upon the analytics. The analytics, as I mentioned, there are two stores. One is variant store and another one is annotation store. Variant store, you can bring your VCF files, variant calling files. And once you imported the variant, you create a variant store and you can just import your VCF files inside. Once the VCF files are ingested, it will be automatically transformed to the structured database schemas. And this structured data tables will be directly available for you in the lake formation. So the lake formation is another service. We try to bring all sorts of different modality of data sets. It could be of a proteomics, or it could be of genomics, or it could be of metabolomics data sets. Lake formation is one container. That container can accommodate different modality of data sets. So this variant store automatically transform your VCF and GFF file and bring it to the lake formation environment, and all the SQL and ETL jobs, extraction jobs might have been done, processed it, and that lake formation will be including the structured data tables. So you can run a small SQL query language on top of those processed data tables, and you will get the insights. So two things: variant store help you to create a variant store, and annotation store will help you to create annotations, all the GFF or annotation store also can accommodate CSV or text files as well. So you can import any clinical demographics files. You should be able to bring it to the annotation store. That will be processed into a schema, but you have the flexibility to adjust the schema for the CSV and the text file, because we have the standard protocol to convert VCF and GFF, but make sure if you're bringing other sorts of file formats like a CSV or tab delimited files, you need to make sure all the schemas are rightly picked up by our services. So once you have done it, you can run the query using Athena, which is our serverless query engine. You don't need to deploy any MySQL server or anything. You can just type Athena in the server console, and you can directly go here, Athena console, and there is a query editor. So you can run the query. All the data tables might be available on the left-hand side as a data source, all the lake formation tables. Then you can run the SQL query by joining your VCF file or cohort of VCF file with the annotation files. So all the outputs will be coming here, and you can import or export these output files for any visualizations or any downstream analysis. So this is the last aspect of the healthomics analytics, how you can transform your unstructured data file formats like a VCF or other file formats into a structured database schemas and allow you to run query to generate the insights. With this, I stop here, and one last thing. So who are all using the healthomics at this point of time? Which almost I covered it. Children's Hospitals of Philadelphia, they have been using the healthomics, and you can see their code. They should be able to expand their understanding of their patient's health all the way down to their DNA. So they have been already using on the public sector side, whereas in the Roche, they have been using in their different platform on how they can integrate different multimodality data sets for their insight generations platform. And we have constructed a comprehensive architecture how you can package the healthomics with the SageMaker, which is another machine learning service. So the ultimate goal for us to guide our patients, what is the better decisions they can get it out of this different analysis, different precision medicine program. So this SageMaker environment can help you to run the analysis across this integrated data set and create the inferences out of it. So whenever the new patient comes in, the new patient will be guided based on our existing inferences prepared by the population sequencing data set or a cohort of data sets. So this architecture, which we have implemented in multiple hospitals, and we are happy to work with you on this to guide your patients on and guide your healthcare policies as well. The last one is we have been closely working with August as well. So any point of contact, reach out to August and he can help you. And we, myself and Charlie, will be a frequent visitor to Jakarta at any point of time, any genomics requirements, we are quite happy to support you for your organization as well as for your companies. Thanks for hosting me and Charlie here, and look forward to working with you. Please feel free to give your inputs on the survey. It is less than 1 minute. 3 or 4 questions might be there, all are multiple choice questions. Feel free to give your input. We are happy to improve on it. Thank you so much, and probably I'm on time, and who is next? I can quickly show you one of the videos we have done before. This is for one of the hospitals in US, actually how they have integrated different population level data coming from genomics, and probably I can share you the slide deck and that may give you the better insights. So they should be able to access and get the insights at the cohort level as also at the individual patient level as well. So different analysis can be performed once you have integrated the clinical data along with the genomics and other metadata informations. They should be able to zoom down at the disease level, at the cohort level, and using the different AWS cloud-based services. The clinicians can easily go there and quickly get the snapshot of his patient's samples as well, and they also can extract at the nationwide projects how they can integrate the different type of disease cohorts and how they can get the different biomarkers from here. With that, Agus, over to you.
Oke, baik, terima kasih. Thank you, Mr. Edwin, for your workshops. It has a lot understanding about AWS computing. Jadi setelah ada acara selanjutnya, kita akan masuk ke sesi brainstorming dan diskusi. Namun sebelum itu, boleh ditampilkan, Mas? Jadi kami mohon ini ada survei untuk yang AWS dan ada feedback dari AWS workshop. Nah, kami mohon bantuannya untuk semua peserta dan rekan-rekan yang ada di sini untuk mengisi kuesioner ini. Kami tunggu 10 menit dimulai dari sekarang. Terima kasih.
Selamat siang menjelang sore, Bapak Ibu sekalian. Mungkin sedikit mohon izin ya, Mas Ijal. Ada yang dari non-hubs BGSi nggak? Dari non-hubs BGSi yang hadir dari bukan hubs BGSi, bukan rumah sakit rumah sakit yang bukan ya, yang bukan. Boleh angkat tangan. Yang meja itu dari PT Pandu bukan? Yang belakangnya, Mas, yang pakai hoodie putih, ya boleh. Shout out Mas, dari mana? Dari mana, sorry? Mas. Mungkin sambil nunggu, salam kenal Bapak Ibu sekalian. Saya Oki Untoro ya dari Technical Advisor di DTO yang bareng-bareng setup infrastruktur buat BGSi. Salam kenal semuanya.
Halo, ya. Saya Edwin dari Exchange Health Initiative.
Exchange
EXEINS Health Initiative.
Oke, base-nya di Jakarta, Mas?
Di Jakarta, ya.
Oh, oke. Servisnya apa aja?
Saat ini sih kita fokusnya ke infectious diseases, penyakit menular gitu. Ada tes misalnya spesiasi malaria gitu.
Oh, oke. Short reads, long reads? Short reads atau long reads yang dipakai? Atau microarray?
Kalau untuk sequencing kita short read itu lewat partnership. Kalau long reads kita ada in-house pakai Minayon.
Oke, Mas siapa tadi? Sorry.
Edwin.
Mas Edwin dari
Exchange Health Initiative.
Indonesia. Oke, thank you. Ada lagi lainnya? Makasih Mas sudah hadir. Boleh angkat tangannya yang dari non hubsnya BGSi. Ya, meja yang ini Mas, tolong dibantu.
Ya, kalau kami berdua dari Balai Besar Laboratorium Biologi Kesehatan.
Balai Biokes ya Mas?
Ya,
dari
Biokes.
Opnyati ya?
Iya.
Oke, makasih. Boleh lanjut Ibu ya?
Saya dari Widya Genomik.
Dari Widya Genomik. Oh, oke. Thank you Mbak ya sudah datang ya. Oke. Mungkin ada lagi tambahan, boleh silakan.
Halo, saya dari Nusantix Jakarta.
Wah, Nusantix, makasih.
Ya.
Mungkin sedikit konteks ya Bapak Ibu. Mungkin yang hubs BGSi, mohon maaf mungkin karena udah akrab jadi sedikit banyak tahulah infrastrukturnya. Jadi ceritanya yang bagian kiri itu adalah kita pengen tahu sebenarnya di Indonesia genomic players itu menggunakan infrastruktur apa gitu ya, dalam artian servisnya apa, infrastrukturnya sekarang ada, nextnya future plans-nya mau apa, kemudian apa sih batasan-batasan yang mungkin dari sisi infrastruktur itu belum ada nih yang sekarang gitu ya di AWS. Nah, kita pengen nampung supaya apa? Supaya kita tetap taat regulasi, tapi kita tetap bisa extend service genomik lebih dari kapasitas yang sekarang gitu. Jadi harapannya mungkin nanti yang online juga kita akan coba belas ya. Artinya kalau misalkan ada beberapa service yang pengen nih gitu, misalkan searching gitu ya, ada service-service AWS yang belum implement di Indonesia, itu kan sebenarnya menjadi batasan ya di kita, karena kita udah punya UU ITE, kita udah punya PSTE, kemudian akan ada UU PDP, kemudian akan ada lagi UU KES dengan turunannya PMK gitu ya, Peraturan Menteri Kesehatan, yang berkaitan dengan regulasi bahwa suatu teknologi yang belum ada di Indonesia itu ada beberapa ini ya, blokernya lah kayak gitu, sehingga kita pengen nih mengakomodasi kebutuhan seluruh genomic player yang ada di Indonesia gitu ya. Kita bareng-bareng coba petain sebenarnya apa sih yang dibutuhin gitu. Mungkin waktu beberapa bulan yang lalu kita sempat workshop juga di office-nya AWS ya. Nah, itu mungkin sedikit sempat dipaparkan juga. Nah, ini memfollow up workshop tersebut. Jadi harapannya kita dapat gambaran lah seenggaknya yang nantinya tentu aja kita akan perlu follow up lebih dalam ya. Artinya ketika memang kebutuhan ini harapannya nggak cuma datang dari BGSi gitu, tapi BGSi di bawah Balai Besar Biomedical dan Genomika Kesehatan bisa membantu mengkonsolidasi nih kebutuhan genomic di Indonesia gitu. Supaya apa? Supaya AWS punya perhatian yang lebih gitu di ekosistem genomik di Indonesia gitu. Mungkin nggak cuma genomik tapi omics ya gitu, omics yang lain, sehingga ada willingness dari sisi infrastruktur untuk AWS deploy di Indonesia, dan juga kita comply nih dengan komitmen beberapa undang-undang dan regulasi yang ada di Indonesia gitu. Jadi kita enggak apa ya, ibarat kata pengen ini tapi kok nggak ada nih gitu. Jangan sampai kemudian dalam tanda kutip ya nanti muncul suatu sentimen negatif gitu bahwa wah ini undang-undangnya ada untuk implement di Indonesia tapi infrastrukturnya nggak disediain gitu. Nah, BGSi meskipun dia sebagai unit UPT BLU, harapannya nanti kita bisa konsolidasi untuk dari sisi regulasinya di Takliankes gitu ya, Direktorat Tata Kelola Pelayanan Kesehatan di bawah Direktorat Jenderal Pelayanan Kesehatan, supaya mendorong genomik di Indonesia ini tumbuh lebih cepat lagi gitu ya. Kita harapannya nanti bisa bareng-bareng melakukan komunikasi yang lebih intens gitu ya, supaya beberapa infrastruktur untuk pengelolaan genomik itu bisa ready di Indonesia gitu. Jadi dari sisi compliance-nya, dari sisi regulasinya sudah dibangun. Nah, ini dari sisi infrastrukturnya kita perlu siapkan gitu sih. Jadi harapannya nggak menutup kemungkinan juga nanti dorongan dari rumah sakit hubs BGSi gitu ya, karena barangkali ada beberapa hal yang masih terbatas nih dengan apa yang infrastruktur sekarang disediakan oleh BGSi. Jadi survei yang kiri itu bisa sama-sama kita pakai gitu ya untuk mengkonsolidasi kebutuhan ekosistem genomik di Indonesia. Mungkin itu konteks dari survei tersebut. Gitu. Terima kasih.
Izin, semuanya udah selesai? Udah selesai ya? Saya lihat baru ada 14, ini ada 2.340 orang. Baru 14. Ada yang masih butuh waktu nggak? Kita mau diskusi habis ini untuk, ada masih butuh waktu untuk submit atau udah semua? Silakan ya, mungkin masih ada 2 menit lagi ya. Ya silakan, 2 menit lagi tolong diisi biar lengkap. Baik, sambil nunggu. Assalamualaikum warahmatullahi wabarakatuh. Saya Yopan dari AWS, Amazon Web Service. Jadi saya Government College di AWS. Selama ini kami membantu Kemenkes dan juga BGSi untuk mengembangkan Genomics di Indonesia. Nah, kita coba diskusi ya bersama rekan saya Mbak Ririn dari BGSi juga, yang nanti juga akan diskusi dengan kita. Mumpung kita semua ngumpul di sini, ini ada dari berbagai macam stakeholders. Jadi kita awalan mungkin terima kasih banyak udah submit tadi. Saya lihat ada beberapa hal. Yang pertama ada rekan-rekan yang pengen AWS Health Omics ada di Indonesia. Tadi kan udah di sharing ya. Boleh nggak ada yang sharing spesifiknya apa? Kebutuhannya seperti apa? Kira-kira ke depan seperti apa? Di tempatnya mau ngapain segala macam. Tanpa saya sebut nama, oh ya silakan.
Cek untuk AWS Health Omics sendiri sebenarnya kita kebutuhannya untuk analisa ya jatuhnya. Jadi kayak output dari sequencing seperti FASTQ, entah itu short read, long read, entah itu dari berbagai platform. Harapannya kita bisa langsung analisa karena kan selama ini kita harus build ulang gitu meskipun itu di AWS-nya, entah di AWS batch atau di AWS step function-nya. Nah kita harapannya kalau AWS Health Omics kan kita ready to use gitu kan. Jadi kayak kita nggak perlu scratch dari awal, dan kalau boleh kayak tadi kan ada yang based on GPU dari awal kan yang dijelasin baru GATK BWA ya, itu kan best practice-nya, tapi kan ada yang pakai GPU dan itu lebih cepat, dan saya pernah cek concordance-nya menggunakan NA12878 juga nggak ada perbedaan gitu. Jadi kayak harapannya sih di situ ada juga gitu, dan kalau boleh kan Clara Parabrik selalu update ya, sekarang sudah sampai 4.3, kalau boleh dari AWS juga menambahkan gitu di Health Omics-nya yang sampai ke versi terakhirnya, karena di versi terbarunya itu ada alignment untuk long sequencing, karena sebelumnya kan belum ada long sequencing yang pakai GPU. Nah di Clara Parabrik yang terbaru itu udah ada long sequencingnya. Udah sih itu dari saya mungkin. Dari Asaren. Ya.
Butuh di Indonesia? Wajib di Indonesia nggak? Harus ya di Indonesia. Mas Agus ya, ini beliau otaknya AWS nih, jadi sambil direkam sama beliau. Ya, sip, thank you. Ada lagi yang lain tentang Health Omics? Butuhnya seperti apa, segala macam? Tidak, ada beberapa soalnya, ada 4.300 yang jawab Health Omics. Jumlahnya cuma 40 di sini ya. Silakan, yang tadi request Health Omics, ada lagi? Itu data wajib ya di Indonesia.
Kalau saya sebenarnya proses di mana aja yang penting data di sini nggak apa-apa. Oh, nggak apa-apa.
Genomics tapi ya. Oke, sip. Baririn ada komen silakan Pak.
Mungkin kita lebih pengen dengar juga ya, maksudnya aspirasi dari teman-teman, karena di sini kita nggak bicara antara kementerian atau misalnya startup, rumah sakit, tapi ini kan sebenarnya suatu movement bangsa. Ini adalah suatu request yang nanti mungkin akan diinitiate oleh kementerian, tapi pengennya kementerian itu ini bisa mengakomodasi semua ekosistem genomik di Indonesia. Jadi kita pengen sebenarnya insight dari teman-teman yang pelaku nih, yang ada sekarang berkumpul di sini, baik dari rumah sakit atau dari startup. Sebetulnya kita tuh butuhnya seperti apa sih? And why do we need it? Karena itu akan menjadi argumentasi juga dari Kementerian Kesehatan bahwa kita udah bilang nih, Indonesia tuh butuh loh. Market genomik di Indonesia itu sekarang udah mulai meningkat loh. Kita pengen health omics itu ada di Indonesia. Tapi kita juga pengen insight nih dari teman-teman. Menurut teman-teman di sini tuh satu, seberapa butuh sih sebetulnya kita gitu. Apakah ini memang menjadi suatu solusi yang akan mempermudah baik teman-teman yang di rumah sakit mungkin untuk clinical analisisnya, kemudian untuk jadi reporting analisis dari rumah sakit, atau mungkin juga dari teman-teman startup yang kemudian punya market di sini dan mungkin berpikiran nggak cuma dari segi klinisnya, tapi juga dari perhitungan budgeting tuh sebenarnya lebih efisien bagi kami pelaku usaha untuk melakukan analisisnya itu di health omics instead of misalnya building our own atau kita punya on-prem gitu. Nah itu yang kita pengen dengar, jadi kayak testimoni dari teman-teman yang ada di sini. Aspirasi teman-teman untuk health omics itu seperti apa? Mungkin yang pertama dari hubs dulu kali ya, dari teman-teman hubs. Mungkin ada perwakilan dari Sarjito, mungkin yang udah ke clinical result juga, mungkin Tias, mungkin juga bisa share seberapa kayak kebutuhan kita ini sejauh ini seperti apa, dan whether health omics is one of the solution yang bisa mempermudah kita juga atau gimana gitu.
Ya, terima kasih. Saya Tias Iksan dari Hubs Sarjito. Untuk is it in English or in Indonesia? Or
bahasa aja.
Oh ya, ada bahasa aja. Jadi salah satu yang paling penting dalam menerapkan genomics di clinical settings itu adalah standarisasi, karena kita ingin hasil yang itu memiliki integritas. Sehingga untuk menuju ke sana, standarisasi itu tidak hanya kebutuhan dari rumah sakit saja, tapi juga nanti butuh support dari pihak-pihak yang lainnya seperti private company untuk AWS yang menyediakan infrastrukturnya, maupun ekosistem lain, stakeholder lain seperti halnya ada GSI, ada Nusantik, ada apalah namanya yang semuanya itu. Kemudian mereka bisa berkolaborasi atau kita semua bisa berkolaborasi untuk menetapkan standar tersebut, paling tidak dalam konteks Indonesia, kebutuhan Indonesia. Nah, beberapa waktu yang lalu sudah dimulai beberapa penyakit prioritas. Kita bisa mulai dari situ. Kalau dari Sarjito itu kita hubsnya adalah rare genetic disease. Kalau kita lihat di rare genetic disease itu tidak seperti halnya cancer atau onkologi yang sudah well established. Artinya ini membutuhkan ya, startnya sudah beda. Tapi start yang beda ini hanya bisa digapai untuk lebih baik apabila ada bantuan dari stakeholders yang lain seperti itu. Kemudian kalau kita bicara terkait dengan genomics application itu tidak hanya pada pemerintah saja sebagai regulator, tapi baiknya itu dari hulu sampai hilirnya, itu sampai ke nanti ada komersialisasinya. Karena mau nggak mau yang namanya ekonomi itu kan driven by profit ya. Kalau nggak profitable maka orang nggak akan invest ke sana seperti itu. Bahkan kan ya untuk AWS sendiri ya, meskipun banyak yang diskonan pada akhirnya kan kalau nggak ada profitnya tidak akan bisa mensupport yang untuk government account atau apa, itu kan nggak akan mungkin bisa. Nah karena itu mungkin ya tadi mulai dari standarisasi, dan itu mulai dari penyakit-penyakit prioritas yang settings oleh Kementerian Kesehatan. Itu ya. Silakan. Terima kasih.
Thank you, Mas Tias. Berarti yang kita bisa take dari sini memang ada suatu kebutuhan untuk standarisasi itu tadi ya, Mas Tias. Mungkin kita juga mau dengar aspirasi lain dari teman-teman dari private sector yang juga ada aspirasi untuk healthomics dari Patgen. Dari Patgen, di mana Patgen? Boleh sharing-sharing sedikit? Atau online?
Patgen ke toilet ya? Oh, ya ada yang lain nggak?
Ada, tentu saja ada. Masih banyak yang menginginkannya. Widya Genomik.
Widya.
Oke, boleh share sedikit, Mbak?
Kalau dari Widya Genomics sih inginnya misal dari pemerintah tuh kalau kita tuh accessible database sih lebihan masih limit menurut kita tuh untuk kan apalagi kita jasanya profiling gen pasti pengen membandingkannya itu dari populasi Indonesia. Nah itu tuh akses untuk data yang di populasi Indonesia tuh. Itu sih.
Berarti mengakses data genomicsnya atau gitu ya?
Iya.
Oke, dibutuhkan untuk
profiling
ya.
Iya.
Oke, jadi reporting lebih banyak ya. Oke. Siap. Baru ini ada lagi yang lain? Ada lagi yang mau ditanyain? Siapa?
Atau mungkin ada yang juga yang sharing bahwa memang ada kebutuhan database yang besar, data storage yang besar dan juga database. Mungkin ada yang mau share-share juga soal kebutuhan-kebutuhan itu. Mungkin ada sedikit konteks kali ya. Maksudnya mungkin untuk database gitu. Ini kan memang sehubungan dengan ulang tahunnya BGSi juga. Jadi di BGSi saya harap sih kita semua udah kenal lah ya BGSi gitu. Jadi in the end of the day yang akan dilakukan BGSi itu kan sebetulnya membuat satu database kesehatan berbasis genomics or probably multi-omics kalau kita bisa kan. Nah database itu yang sebenarnya nanti akan kita share ke teman-teman semua. Semua orang di Indonesia, peneliti, klinisi dan lain-lain sebagainya. Nah tadi kan juga ada tuh sedikit rangkaian materi hari ini mengenai trusted data sharing platform. Untuk terutama mungkin ini lebih ke teman-teman yang bergerak di dunia private ya. Bisa mungkin share sedikit sebetulnya kebutuhan teman-teman di private sector seberapa besar sebenarnya dalam mengakses data ini gitu. Misal nih nggak apa-apa sih, nggak usah ada BGSi, data yang lain juga ada gitu. Atau misalnya kayak enggak, jadi kami sudah melakukan ini dan ini dan ini dan memang ternyata ada gapnya. Nah itu kita pengen denger testimoni real dari pelakunya langsung. Mungkin ada teman-teman yang dari startup juga mau share di sini. Di sini data kita selain tadi ada Exein, ada Saren, ada Widya Genomic, ada Patgen. Kemudian ada teman-teman dari mana lagi? Dari rumah sakit ya yang pasti. Nah itu ada yang kira-kira bisa disampaikan mungkin dari Asaren? GSI nggak ada di sini ya? Ada juga GSI. Coba habis Asaren mungkin kita mau dengar dari teman-teman GSI juga ya karena GSI kan juga ada risetnya juga toh. Oke, silakan Mas.
Cek sejujurnya untuk database terutama yang korelasi antara genetik sama disease tertentu gitu. Untuk yang Indonesia sendiri dan ada di Indonesia sejujurnya sampai sekarang saya belum menemukan, entah mungkin dari BGSi sudah ada yang melakukan konsensus atau belum, saya belum tahu. Tapi sejauh yang pernah saya explore, saya menggunakan memang data dari global dan dari global pun dia terpisah-pisah gitu. Misal kayak dari Jepang sendiri, kemudian dari China juga China sendiri, Amerika NCBI pastinya, dan kemudian dari Europe pasti AB gitu. Dan dari situ pun data yang mereka provide itu sebenarnya cukup besar. Ada beberapa populasi yang mungkin mendekati Asia Tenggara, tapi spesifik Indonesia pun tidak ada. Dan sejauh saya eksplor untuk Asia Tenggara, yang cukup ada datanya dan open source itu Singapura, meskipun datanya belum terlalu banyak. Nah, jadi harapannya dari Indonesia mungkin bolehlah mengumpulkan data-data, terutama kayak bagian rare disease atau korelasi antara genetik dengan disease, meskipun itu bukan penyakit rare disorder gitu. Dan terutama mungkin bisa di apa bahasanya, harmonisasi mungkin ya, kayak prevalence di Indonesia itu sebenarnya berapa untuk disease ini gitu. Karena untuk perhitungan, karena saya sendiri data scientist, ketika nilai prevalensinya berubah yang antara di Indonesia dengan di luar, itu ada gap yang lumayan, bukan gap sih, jadi kayak rentangnya itu cukup jauh gitu. Jadi akan mempengaruhi beberapa kalkulasi yang saya lakukan gitu, sejauh saya explore itu.
Thank you. Dari GSI mungkin ada dari GSI?
GSi ya?
GSI.
GSi.
Kalau enggak mungkin kita mau dengar juga perspektif dari peneliti ya. Di sini kan ada teman-teman dari BRIN, di meja yang mana ya? Kalau dari data sih ada dari BRIN. Oh iya, kalau perspektif peneliti sendiri seperti apa, Mas?
Ya, kalau dari peneliti sendiri sih, kalau dari BRIN sendiri itu belum mengarah ke human ya, masih tatarannya masih yang hewan, terus juga yang tanaman, bakteri. Untuk human kan memang kalau dari sisi alat memang kita sudah punya tuh, yang dari yang karena kita kan BRIN sendiri itu kan mengumpulkan resource dari berbagai, makanya digabung dalam satu BRIN itu kita mau mengumpulkan resource. Dan itu sebenarnya tujuannya sendiri itu untuk resource sharing sebenarnya juga. Namun terkait data itu memang masih belum mengarah ke human gitu, masih kami belum memiliki data seperti itu gitu. Mungkin karena saya dari organisasi riset elektronika dan informatik, itu titik beratnya hanya kepada toolsnya saja. Adapun data sebenarnya kita punya organisasi riset kesehatan, mungkin ada beberapa peneliti yang dari organisasi tersebut udah concern ke arah sini. Cuma kita belum ketemu aja orangnya siapa gitu. Karena di BRIN sendiri di dalamnya itu ada beberapa organisasi riset seperti itu.
Terima kasih. Mas Yopan mungkin ada pertanyaan? Mari Mas Yopan.
Ya, dari AWS sendiri kami coba untuk collect kebutuhan tentang Omics ini. Jadi Omics ini kan tadi seperti disebut ya, harus ada di Indonesia. Nah sekarang ini udah ada tapi belum ada di Indonesia, kita mau bawa ke Indonesia. Jadi kenapa kami tadi coba tanyakan, kita mau coba justifikasi juga berapa besar. Itu dari sudut pandang kami. Sudut pandang Kemenkes pastinya juga butuh juga nih berapa banyak orang yang akan pakai ekosistemnya kan, gitu ya. Makanya menurut hemat saya, kalaupun di sini nggak terungkap, ini kayaknya harus ada komunitas gitu Mbak Ririn ya. Kita sering-sering ketemu segala macam. Intinya Kemenkes akan memfasilitasi semuanya, AWS akan menyediakan teknologinya, tapi kita butuh ekosistem gitu, buat teman-teman semua. Jangan sampai dari teman-teman misalnya ngambil data dari luar, kan sayang banget ya, gitu ya. Padahal disediakan juga sama Kemenkes, gitu. Nah, jadi sebisa mungkin kita bisa punya banyak data point untuk kita kerjasama bareng. Ada lagi yang lain mungkin ya, yang mau komentar? Atau mungkin ke depannya nih, kalau sekarang mungkin belum, tapi ke depannya kayak apa tuh? Ekosistemnya mau dibangun dan dibutuhkannya apa dari teknologinya dan juga dari Kemenkes? Ada yang mau komentar nggak? Ada lagi yang udah mengisi? Baik, belum ngisi ya? Yang udah ngisi? Oh, ada. Saya mau bilang yang sudah ngisi nanti di depan ada kunci Alphard, silakan diambil.
Ya, terima kasih untuk kesempatannya. Jadi sebenarnya mau menambahkan dari apa yang sudah disampaikan sama teman-teman dari Widya Genomics dan Nasaren. Mungkin itu concern yang cukup sensibel ya, mengingat kalau dari kebetulan saya dari Nusantics, jadi kalau misal we have the technology, tapi kalau kita nggak ada datanya yang mencukupi gitu, kalau misal sample size-nya for instance, untuk data klinis kan kita pasti butuh data yang besar banget. Nah itu kan seringkali dari swasta sendiri itu bisa dibilang untuk mendapatkan data tersebut ya kita perlu effort yang lebih besar gitu. Nah kalau misal benar apa yang dibilang, jadi misal kalau kita punya suatu konsorsium yang nantinya menghubungkan antara tim dari rumah sakit nantinya misal dan juga tim dari swasta, saya rasa itu akan sangat bagus sekali karena mungkin dari di rumah sakit kan pastinya tiap harinya ada data klinis yang baru seperti itu, ada pasien yang admitted to the hospital gitu kan, jadi nanti datanya bisa dikumpulkan bekerjasama dengan swasta untuk kita bisa mengakselerasi dari nggak hanya dari data analisisnya tapi juga dari data collectionnya seperti itu. Jadi nanti misal kalau udah ada konsorsium tersebut, saya rasa nantinya kita bisa come to common terms gitu. Jadi nanti dari rumah sakit bisa di-provide apa dari swasta, nanti dari swasta pun butuh bantuan provide apa gitu dari rumah sakit. Jadi when we come to the common terms kan harusnya nanti bisa lebih mudah ya. Saya rasa itu sih. Jadi kalau once kita datanya sudah banyak dan kita bisa akses bersama nanti, jadi mungkin kita bisa fokus untuk dianalisanya setelah itu. Dan saya rasa itu akan cukup efektif sih untuk mengakselerasi si pertumbuhan genomika itu sendiri seperti itu. Oke, terima kasih.
Apa kita bikin asosiasi aja? Bisa ya?
Untuk yang belum tahu, mungkin memang di Indonesia ada beberapa asosiasi ya. Mungkin kita bisa mulai dari yang udah existing, misalnya ada Asosiasi Genomik Indonesia (AGI), kemudian ada INA SHG, Indonesia Society of Human Genomic gitu. Itu juga ada. Tapi mungkin kalau misalnya nanti perlu khusus untuk human genomic tapi yang bioinformatics, nah kita bisa bikin juga itu. Bisa diinisiasi loh Mas, mungkin Mas Santi.
Ya perlu juga. Kita angkat presidennya aja sekarang.
Oke, ada lagi yang mungkin mau share lagi mengenai, atau mungkin ada terkait juga mungkin ya masih mengenai database, mengenai healthomics. Kalau tadi lebih ke harapannya yang di AWS, nah ini mungkin harapannya untuk ke kementerian sendiri seperti apa? Ada yang mau mungkin justru dari teman-teman rumah sakit, dari hubs, apa sih yang sebetulnya nah nanti aku GR ya bilang kayak we've done something lah ya Kementerian Kesehatan kan, we've done something but what can we do better gitu. Ada yang mungkin mau share kayak oh ya sebenarnya Kementerian Kesehatan harusnya lebih begini, lebih begitu. Mari silakan, ada yang mau angkat tangan? Gak mungkin dong ya kementeriannya udah bagus banget kan, emang bagus sih tapi kan gak mungkin bagus banget ya, pasti ada yang kurang dong. Oke, ada yang mau menyampaikan? Untuk yang rumah sakit jangan khawatir loh, di sini komplain tapi tidak akan mengurangi akreditasi rumah sakit. Jadi silakan angkat tangan. Ada nggak? Mungkin dari hubs ya. Kalau tadi udah Sarjito, mungkin kita ke hubs Darmais. Darmais. Tuh. Kira-kira Dok.
Ya, gimana Mbak Ririn tadi?
Kira-kira ada yang ingin disampaikan, perbaikan ataupun misalnya kayak masukan ataukah permintaan ke Kementerian Kesehatan gitu terkait ekosistem genetik kita atau genomik kita di Indonesia.
Ya.
Tapi jangan minta storage yang lebih besar ya, Mas.
Iya. Makasih Bu Ridin. Mungkin ini melengkapi dari teman-teman yang tadi sudah sampaikan. Sepertinya sudah disampaikan semua. Sebenarnya memang kita sebenarnya butuh semacam dalam tanda kutip playground kayaknya untuk main bareng gitu antara kementerian sama swasta. Kayak mungkin kita dari rumah sakit pemerintah paham dengan apa yang kita punya, tapi mungkin nggak punya kapasitas penuh untuk bikin sesuatu yang benar-benar fully implemented gitu. Nah ini sebenarnya kita pengennya sih ada sesuatu yang memang bagian-bagian yang memang bagian dari Kementerian Kesehatan dan perpanjangannya mungkin dari rumah sakit pemerintah. Nanti bisa kita kolaborasikan juga dengan teman-teman dari swasta, kira-kira bagian-bagian mana yang jadi part-partnya gitu. Harapannya sih mungkin ke depannya gak cuma database tapi memang benar-benar bisa jadi sesuatu yang memang berdampak klinis yang memang benar-benar bisa dimanfaatkan untuk masyarakat sih sebenarnya itu. Karena memang dari kami ngerasa untuk saat ini mungkin lebih fokusnya lebih ke karena memang lagi generate data gitu ya. Jadi berhubungan ngomonginnya data gimana caranya sinkronisasi antara data di pusat terus di hub gitu kan. Tapi mungkin ke depannya kita akan banyak nanti mainnya datanya kalau bisa database-nya di satu tempat gitu. Jadi nggak kemana-mana. Jadi bisa benar-benar semuanya ikutan pooling di sana, analisis di sana, terus nanti apa yang kita bisa kerjakan, kayaknya itu akan jadi sesuatu yang lebih punya impact dan menghasilkan suatu produk yang memang lebih nyata sih kayaknya. Mungkin dari saya itu ya Bu Ridin.
Makasih Mas. Ada lagi ini rumah sakit tapi yang bukan rumah sakitnya BGSi ya. Mungkin kita juga pengen dengar juga pendapatnya dari RSUD Budi Asih.
Budi Asih?
Atau online? Atau sedang coffee break?
Tadi dari patogen ya yang lagi ke toilet? Lupa saya, patok tadi. Yang patgen.
Okay.
Patgen jadi patogen. Patgen ada di sini tadi? Yang ke toilet? Nggak ada ya?
Kalau nggak dari Respon. Pon.
Betul. Beliau. Respon lagi ke toilet.
Lagi.
Kenapa selalu di toilet dipanggil?
Ya udah, yang di belakang aja. Harapan kita jantung. Ayo.
Harapan kita.
Harapan kita. RSJPD. Iya kan.
Ya, terima kasih Bu Dirin. Mungkin kalau dari kami RSJPD harapan kita masukannya mungkin kalau tadi Mas Reza kan win-win solution antara negeri dan swasta. Mungkin itu bisa dituangkan dalam bentuk suatu pedoman ya. Jadi itu pedoman tersebut tuh bisa turun ke kami di Satker sebagai suatu panduan. Jadi yang mana yang diperbolehkan, yang mana yang tidak diperbolehkan gitu. Karena kan memang banyak sekali nih swasta-swasta yang memang mengajak kami untuk kolaborasi gitu dalam banyak hal karena memang kami juga memiliki sumber daya manusia dan juga sumber berupa sampel sesuatu hal yang tidak mungkin apabila pedomannya belum dibuat dari kementerian. Sedangkan dari rumah sakit sudah mendapatkan tawaran yang seperti itu. Kami sendiri juga sudah membuat panduan, namun kan panduan tersebut tidak memiliki dasar hukum yang kuat dari kementerian. Mungkin seperti itu.
Ya, panduannya ini apa nih? PMK atau nanti Mbak Ririn ya kerjanya bikin panduan ya? Mas Oki, ada komen? Pembuat panduan? Silakan Mas Oki.
Sorry, tadi pertanyaannya dari siapa ya? Ya.
Jadi ada kebutuhan untuk tadi kita dengar ada playbook, playground, kemudian ada juga kebutuhan pedoman dari RSJPD harapan kita.
Oh, dari harapan kita. Mana sih? Mbak Elok ya? Oh ya, ya Mbak. Ini sambil duduk nggak apa-apa ya. Sebenarnya saya berharap bukan hanya sebagai pedoman ya, tapi karena kalau pedoman itu kan seolah eksklusif buat hubs aja gitu ya. Tapi kalau kita berbicara ekosistem genomik secara lebih luas di skalanya nasional, ranahnya sebenarnya approach paling tepat secara non formal seperti yang dibilang Mas Yopa tadi ya, komunitas dalam tanda kutip. Tapi kalau secara formal itu naungannya di regulatory sandbox. Nih teman-teman yang dari health tech, yang dari private, ada yang pernah aware dengan regulatory sandbox belum ya? Ada yang udah ikut regulatory sandbox-nya Kemenkes? Belum ya? Nah kalau tahun 2023 itu fokusnya di telemedicine, telekesehatan, telekonsultasi dan lain sebagainya gitu, dan kayak marketplace obat gitu. Nah itu supaya mewadahi health tech untuk compliance terhadap regulasi. Nah di situ ada 3 layer gitu, ada 3 stage. Diawasi, dibina, direkomendasikan. Jadi kayak kalau direkomendasikan tuh kayak fintech dapat cap OJK. Nah dari situ sekarang itu posisinya ada 8 startup yang statusnya itu direkomendasikan. Jadi dia udah comply dengan regulasi dan sudah melakukan integrasi dengan Satu Sehat. Tapi konteksnya Satu Sehat ya RME. Nah kalau konteksnya genomik ini untuk tahun ini masih sebenarnya udah ditutup regulatory sandbox dan itu tidak spesifik dibagi health tech dan genomik atau biotech gitu. Sepertinya ada beberapa biotech atau perusahaan private yang bergerak di bidang genomik gitu ya, yang juga daftar, saya juga nggak hafal, tapi itu harapannya bisa menjadi apa ya, start awal lah gitu untuk compliance terhadap regulasi. Jadi sebelum spesifik ke hubs, ini broader nasional dulu ya, izin ya Mbak Elok. Jadi regulatory sandbox itu sebenarnya tahapan yang paling atasnya, karena 2 layer di bawahnya itu untuk startup yang dia masih mencoba untuk mandiri, yaitu di innovation lab dan industrial sandbox. Innovation lab itu jatuhnya ketika dia mau testing idea, ini valid nggak? Industrial sandbox dia mau dapetin market. Nah regulatory sandbox ini biasanya dia udah dapat user, udah dapat market, dia udah mandiri dan bisa kasih usulan regulasi ataupun kita bareng-bareng dalam tanda kutip merencanakan gitu ya, atau menginginkan suatu infrastruktur yang sesuai dengan kebutuhan atau bahkan merencanakan apa yang ke depan gitu, capacity planning. Nah cuman ranah itu tentu saja di Kementerian Pusat gitu ya, seperti yang tadi disampaikan, kemungkinan bagusnya ya di Direktorat Takaliankes. Nah, karena BGSi ini di bawah Biomedical yang dia sifatnya UPT, nanti sifatnya rekomendasi gitu ya, terkait regulatory sandbox ini seperti apa. Tapi pelaku yang bekerja itu adalah untuk sejauh ini adalah Satker dan juga Pusdatin gitu. Kalau kemarin Pusdatin TTO. Nah mungkin untuk tahun ini saya nggak tahu apakah ada yang mendaftar dan cukup banyak yang biotech dan itu akan dinaungi, atau itu di hold sampai regulatory sandbox tahun 2025. Nah itu untuk ekosistem ya. Nah kalau spesifik ke penggunaan infrastruktur yang ada di sekarang ya di BGSi terkait regulasi, karena memang dari sisi regulasi itu ada 3 ya acuannya. Yang pertama UU ITE, yang kedua UU PDP, yang ketiga UU Kesehatan. Yang sekarang masih dijadikan patokan itu adalah UU ITE karena dia punya turunannya PSTE. UU PDP harus menunggu lembaga PDP-nya. Mungkin kalau ada yang sering pakai LinkedIn udah sedikit berputar cukup banyak informasi terkait UU PDB yang bisa jadi mulai berlaku tahun ini. Yang ketiga terkait UU Kes yang nanti turunannya dari akan ada turunannya PMK ya Mbak Ririn ya. Kemudian akan ada RKMK penyelenggaraan BGSi itu Mbak Elok. Nah nanti di dalam RKMK itu kita bisa membuat kalau nggak salah surat edaran dirjen atau keputusan dirjen, Kep Dirjen untuk mengatur mekanisme tata kelola yang tadi disampaikan Mbak Elok itu. Jadi karena UKES-nya udah ada, akan ada PMK, kemudian PMK terus RKMK penyelenggaraan BGSi. Nah nanti itu jadi cantolan untuk bikin SE Dirjen ataupun Kep Dirjennya gitu. Nah apakah itu cukup menjawab atau perlu yang lebih detail lagi? Cukup Mbak Elok. Oh ya, terima kasih.
Ya, thank you Mas Oki. Kita sampai di akhir acara. Sebelum kita foto bareng untuk closing, jadi terima kasih banyak untuk peran sertanya. Kami tadi udah catat juga di form dan juga teman-teman udah sharing ya. Jadi izinkan saya buat sharing kesimpulannya. Yang pertama dari teman-teman baik dari rumah sakit, dari swasta, dari researcher semuanya butuh akses untuk ke platform ini. Jadi nanti Kemenkes BGSi sedang bikin platformnya. Nanti teman-teman bisa akses ke sana supaya dapetin data yang lengkap, yang komprehensif dan seterusnya. Yang kedua dibutuhkan panduan dari tata kelola ya yang sekarang lagi dibikin juga. Semoga nanti surat edaran atau keputusan dari dirjennya bisa keluar sebagai tata kelola. Yang ketiga semuanya setuju bahwa perlu ada teknologinya. Jadi Healthomics nanti akan coba kita bawa ke Indonesia supaya teman-teman bisa comply dengan data residensi ya di Indonesia. Yang terakhir kita akan bentuk grup. Nah, semacam konsorsium itu. Kalau berkenan nanti teman-teman akan kita invite ke dalam WA group, boleh ya? Kita bisa follow up di situ. Kalau nanti setelah diundang mau bawa temannya lagi silahkan. Atau bawa rekanannya, bawa bosnya, terserah. Kita bisa diskusi bareng. Dan saya berharap kayak acara kayak gini bisa dilanjutin Mbak Ririn ya. Mungkin kita bisa setiap hari. Oh enggak, itu berlebihan ya. Bisa sebulan sekali atau quarterly kita diskusi. Karena perlu update juga nih dari Kemenkes kan pasti banyak perubahan ya, ada update segala macam gitu, nanti kita coba follow up juga. Kurang lebih itu ya summary-nya. Pertama semua orang akan bisa akses ke platform. Yang kedua kita coba bikin tata kelolanya. Ketiga kita sediakan infrastrukturnya berupa Healthomics. Yang keempat nanti kita bentuk grup untuk bareng-bareng supaya bisa kita follow up lagi. Sekian dari kami untuk hari ini kita tutup acaranya. Terima kasih banyak untuk kehadirannya. Salam buat keluarga di rumah dan juga teman-teman di kantor. Semoga kita bisa berjumpa lagi. Dan terakhir kita coba foto bareng, boleh ya? Ini muat gak ya? Cukup ya? Oke, muat ya? Oke. Teman-teman silahkan dari yang belakang, ujung kiri, ujung kanan, yang di pojokan, yang di toilet silahkan semuanya ke depan. Kita menghadap ke sana. Yuk. Setelah ini kita bisa pulang. Yuk.
Bu, mohon perhatiannya. Mungkin berdirinya agak lebih rapat lagi, boleh? Lebih rapat, kalau bisa dibuat 3 baris. Mungkin yang cowok-cowok bisa di bawah mungkin ya, biar kelihatan semuanya. Sorry, jangan sampai ke bawah Pak, sorry Pak. Di atas saja tetap cuman gaya pemain bola. Baik. Sini Pak. Oke, yang lainnya bisa menyesuaikan posisinya. Ya, supaya semuanya terlihat ya. Oke, yang sebelah kiri kayaknya agak lebih padat ya. Mungkin bisa geser ke sebelah kanan atau bisa geser sedikit. Iya.